All right, here we are live. Welcome to my stream today. I'm trying to count. I think this is probably the fourth or fifth time I've tried to do server components on stream. It's probably the fourth official time in terms of part of the title. Technically, I talked a lot about server components when I was talking about Solid 1.6 release, but it's funny. Maybe not that funny, but those streams have been my lowest watch streams of pretty much all time. And the last one with Next 13 was like a little bit more. Sorry, let me adjust my mic here. A little bit more traction, so to speak. But like, there's been for quite some time a surprisingly low amount of interest in server components. Yeah. People like signals. Yeah, but these things are not mutually exclusive. It's funny. There was actually a React tweet, a couple of them I've seen recently, where they're treating these things as exclusive, and it's just so funny to me because like I forget which one it was, but there was one there. They're like, when you got server components, no one's reaching for signals, but also when you have server components, no one's reaching for use state. Like it's just such a bad comparison. You know what I mean? If you have server components, no one's reaching for use effect. Like these are like not at all the same kind of realm of things. Yeah, it was a scheduling thing. I already had the thing. His thing was on Wednesday. I had the module extraction thing yesterday, and I had this stream today. And to be fair, I was going to talk about this anyways. If you remember, about a month back for my birthday, I canceled the stream. I was actually going to talk about what I've been wanted to talk about today on that stream about a month back. So it just the timing sometimes works out like this, where everyone's talking about server components this week and everyone wants to talk about it. And I watched that live stream of Kent and Dan and Joe, and watching that was like the final push. I just like made the stream title and pushed it out the door when I saw that stream, because like as much as they did a decent job of talking about it and getting thing, I think this is a topic that it's best to talk about like outside of React. Because people get really into like the minutia of detail, and we will get there, but it becomes this like really awkward scenario, like as part of that stream where they're like Remix versus React or whatever, or Next and all this stuff. And it was like that, like the framing starts off in the wrong position before you even get started. Like what can RSCs do for me? And I think it comes completely a problem in the naming. So yeah, we'll talk about all that today. I'm still killing time right now, right? Getting people past those Twitch ads. I should actually tweet out here that we're live, just in case a couple people actually do want to talk about this stuff. Because as I mentioned, quote tweet. Was it Twitch TV/Ryan Solid? Sorry, I just like got caught up in that. It's just I watched this stream actually. There's been like a ton of really good server component content this week. I watched the stream yesterday with Ben Holmes, and he was looking at some library that Daishi, Zustand and Jotai and Valtio, or however you pronounce all the state libraries. He's like, oh, look here, a minimal server components framework. And this was really cool to kind of see it broken down to its mechanics. But like, even I remember when he was experimenting with it, the React team was like, hey, you're holding it wrong. And I think everyone needs to have that moment to get past the we're holding it wrong, which is why I wanted to do this stream. Because like, funny enough, like most technology, that's around right now, that we're working on. Server components, like as we know them as server components, are new, but structurally, architecturally, they share an incredible amount with technology that's been around for almost a decade. So I think if you instead look at it from that perspective, get out of your React zone of life and look at the fact that this is almost a logical place where things could go, then we can have a real conversation about what the merits of server components are. Yeah, I mean, this is the thing right now. There's a lot of experimentation going on right now. He tried to use the server components implementation, like reference implementation, outside of the React repo, and then he needed Java to build that, and it was crazy. Honestly, if you want to use server components today, use Next.js. React team told you that. Like, go use Next.js. People are going to play with it, make their own stamp on it, but like, honestly, these things take refinement. This is a new and old thing. But for us in modern declarative front-end world, it is a new thing. And there are rules and patterns that should be followed that make sense, but wiring it all together lets you currently kind of get into a mess of things. So I want to cover all that. I want to cover the difference between what I like to dub as lakes and versus islands versus donuts. I know we got all these shape metaphors and a lot of things that include water, like streaming, and like I've talked about these at length on my stream previously, but it's always better when you have a specific goal or task in mind and purpose. All right, so how are we doing? People starting to join in. As I said, I suspect this will be smaller than some of my recent streams. There is a surprising little interest in server components, which is bonkers to me, because you see it even on Twitter that there has been like building up this week. But in general, I've noticed that like most people are like, why do I need to care about this? And they're just like, if they see something with server components on, they're like, I'm not going to click on that. And it's an interesting place to be in, to be sure. Oh man, you all are great. Yeah, I mean, it is back to the monolith. So does this start with a history lesson? Like, my idea, kind of overarching thing about what we're going to do today, it's going to involve a lot of escaladraw, okay? And it's going to involve looking a little bit at the history, then understanding React's design decisions, perhaps. And then I've been working since last October on documents to describe or spec out how I'd make an agnostic, like not even agnostic, I don't like the term agnostic, but make server components for every framework. But agnostic is a possibility there. Like, basically, what if I took Astro today? Could I just make Astro my server components and have every framework just have server components? Bing. I think the answer to that is actually yes. But obviously, Astro would have to change it. I'm not telling them to do that. I'm just putting it out there that we are talking about an architectural change. This is not like people go, oh, this is React's latest feature, like hooks. No. This is more like what happened between going from multi-page apps of the past, like Ruby on Rails, to single-page apps, like Angular or whatever, in the first place. And I think whenever there's that kind of level of architectural shift, there's like, people have to ask the why. Is it worth it? And that's a fair question, and the answer is often complicated and involve many, many trade-offs. So let's try and like narrow that down a bit today. Yeah, and I want to. The title of this stream is Server Components and Server Functions, and the reason for that, because there's a nod to this, is all part of the same thing. I am not surprised that all the solutions seem to be aligning in the exact same zone, having very similar mechanics, even if they've like changed their syntax slightly differently. And I want to talk about, so when I talk about this holistically, we're going to be talking about data fetching, we're going to be talking about mutation, we're talking about the whole architecture of what this looks like completely from end to end, not about like what's not in React or Next yet or whatever. No, I'm going to hypothesize here. I don't know what the next guys are working on. I'm sure it'll be cool when we see it, but like, I'm going to talk about this as if I've already designed the future framework that we haven't seen yet. Because like, to me, I think it's already there. There's details to work out. There's a lot of small things, but higher level, this is an architecture that covers the range. It passed the base set of tests that are required, from my perspective, to be legitimately a thing. Okay. Is that a good intro? That worked for people? We're also going to have a great This Week in JavaScript too, as always. Lots of fun. But we'll see how we get there when we get there. Have I seen it? SSR is not server rendering. Don't read into it too literally. We can talk about that. I feel like the average developer doesn't care about experimental state. You're right. They don't, and they shouldn't. So, if you come on my stream, you probably care a bit more about the experimental stuff. But maybe it would be helpful if we could understand why the experimenting is happening in the first place. And the answer to that, as I said before, is not a single avenue. It's not just because we're bored. And it might not even be because you need it. Okay? But it doesn't change the fact that this is potentially quite a good thing. All right? Yeah, I'm curious about the downsides of server components. We'll get into that too. Yeah, well, I mean, we have to go back there. So should we get back there? Okay. Yeah. So my first statement here, and this is going to remove all the nuance out of this, because there's tons of nuance that I'm not going to say here, is server components are the islands architecture. Okay? Straight up. They are the islands architecture. There is obviously considerations about routing and about, data loading, state preservation, all that stuff. But for you coming in today, I'm just going to put it out there that high level, you step back, we are talking about an extension, a variation on the islands architecture. To understand this, I want to talk about it in two modes. I want to talk about this in terms of developer experience and in terms of performance. Or UX. We need to talk about both of these to understand why this is important or valuable, because we spend a lot of time talking about performance and we don't spend time talking about what the actual experience of creating this is. And for all the really nice benefits we have of current modern single page apps, there are inherent trade-offs and complexities that come with it. And if you go back to the beginning of the web, things were kind of simpler in a certain way. You couldn't do as much, but things were simpler in a certain way. Let me see, chat, how are you doing? Yeah, that's a cool idea. I might consider doing that in the future. Right now, just use chat. I'll do my best. It's the thing is with chat, I can keep on rolling, be more selective. The thing with the Discord thing, I think the Discord approach might be better with like a audio channel kind of situation, you know, like where where you're actually like doing an actual dedicated Q&A, because then you can like focus on that. I'm gonna try and keep a narrative stretching through this whole thing. Okay. And actually, I'm going to open Twitch in my other window just so I don't miss any of you Twitch subs and people coming in. I always miss you when I'm in my StreamYard. So this is just to make sure that I don't miss any of that. Okay, perfect. I think we're all set up now. There we go. Okay, cool. All right. So we also can't fetch Astro components from the client yet. Yeah, how should I put it though? That's the wrong way to think about it, in my opinion, and we'll get there. Okay, so I don't know if I'm going to need to even draw some stuff here at the beginning, because I hope that this is kind of common kind of knowledge. But if you go to a website, okay, like I'm starting right at the beginning here. And you go to the, you know, a different website. Let me find an MPA app. Yeah, Google search an MPA. You know, you do something, you navigate, you post some information, you come to a new page, you know, go to the next page. Basically, with no JavaScript, I'm sorry, this is like the most basic thing. The experience of actually navigating and doing updates is actually rather simplistic. You can do it all in HTML. You have anchor tags, which lead you to the new place. Do a GET request. You have forms, which you can post some information and refresh that page or navigate to a new page. Right? I'm just putting this out here because you have to start. You don't get to server components from starting from a single page app mindset. You get to them from like starting from web fundamentals, right? And the reason I'm just bringing this up here is that this model is very, 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 very simple. Okay, and this is for all the benefits that come from single page apps, you lose a bit of that simplicity. Rich Harris, I'm gonna just grab a talk here just in case people haven't seen it. I'll link it. I'll talk about the details, but you can see it later. Transitional apps. This is from Jamstack Conf a couple years ago. What was it? Jamstack TV. Have single page apps ruin the web, right? I'm just gonna grab this talk and put it in here, because this is a great talk talking about the trade-offs of single page apps versus multi-page apps when you consider stuff like routing. You suddenly have a whole new bunch of considerations around how you handle the browser state, scroll state, how you handle, you get new powers because you can handle transitions. But at its core, you can basically see that these things do have trade-offs. Okay, I'm not going to focus too much on specific trade-offs right now, but I wanted to kind of highlight the fact that that when you start along this path, there was clear gains of going to single page apps, but over time it's caused the model to be one that makes sense, a client-centric model that requires basically all the JavaScript to be in the browser. Okay. This part is fairly straightforward. I think everyone kind of understands that. Like when you have an SSR app, and I'm trying to decide if I should bring up a couple of my old articles here because they really cover the key points. But what I want to get at is SSR as we know it today in single page apps are still single page apps. Okay? By that I mean you might have rendered it on the server, but when you navigate to the next page, you need to render the whole thing in the client. So this has a few prerequisites right off the top. It means that you have a client-side router. Okay. It means you need all the code upon route change to fetch that data and load in the code to render that page. It means that what's another one? It means that if you move between pages multiple times and you don't want to refetch the data again, the browser is the one that's aware. Like you have in the browser, you're going to have a cache that says, "Hey, I already fetched this data. Don't fetch it again." Right? In our old multi-page app scenario, you could cache the page result, but generally speaking, all of those decisions had to be made on the server on each page. Where in a single page app, even a server rendered single page app, you are making all those decisions in the client. And what this means is you need JavaScript to do it, which is fine. The router might not be that big. The client rendering, the loading can be deferred, for the next page you go to. But the cache is a little bit something large. Have you ever seen, like, if you want a really powerful cache, ever bundle Phobia to Apollo? The reason I bring out Apollo is the reason I call it Apollo is that Apollo has one of the best client-side caching systems. Relay is going to be another one. GraphQL found a way for us to have the most control over that client-side cache because we understood exactly what data needed to be fetched, grabbed exactly what we needed. It's like the perfect design for an API for mobile, like for a very client-heavy application. But it comes with a cost. And the biggest challenge we have on the web is still like a server client model, and that cost is not free. 43 kilobytes plus 42 kilobytes for React would have been pretty much absorbed your complete performance budget from like an Alex Russell article from about maybe I want to say like 5 years ago. 5 years ago is a long time ago, but I just want to point out that these libraries were basically just as big back then. And for people using devices, not the top end devices, around the world. And I'm giving you the performance argument right now, just because I think I need it for setting. But if you've ever seen Alex Russell's, what's his inequality gap? Every year or two, he writes stuff and he takes real performance numbers, and again, you might not have customers around the world in that, but what he shows is stuff like this, where he shows how the processing power and like the actual devices have changed over the years. The scary part about this is, iPhone's going up, flagship Android's going up. Cheap Android isn't actually going up. It's actually been flatlining. So while the low end has been able to almost double, since the time that he said this 80 kilobytes, it's not like what everyone else is experiencing, right? It's actually on the low end side. These devices here are like over a decade on CPU. And when you add slow networks into the consideration, you do all the math. Look, this might not be your customer. You might not have to worry about it, but there is something to be aware of. And this is not, if we take this graph and line it up with a graph about the average size of JavaScript on websites, you're going to see that the JavaScript on websites follows like maybe like the galaxy curve. Like it's keeping in check with the average, flagship Android phone, but it's actually not keeping in check with the low end devices. Okay. I but I don't think of it. Yeah. I mean, okay. So I just want to frame it. I'm not saying I'm saying this is something everyone should be aware of, right? So I wanted to kind of at the very big basis of our discussion today, talk about the fact that at one point web pages were literally just link and post a form. You didn't have to worry about writing to your query cache. You didn't have to worry about complexity about cache invalidity. Basically, client side declarative single page app development is just cache manipulation. That's 90% of your job. I mean. On the mechanical side of the app, yes, you have to do UI. There's CSS, there's styling, there's design, there's interaction, UX, whatever. But I'm saying from the performance mechanical side of the job, it's mostly you could view it as a transformation of a data cache, right? But yeah, I mean, who cares about this? eBay cares about it. Meta might sometimes care about it, though it's very funny. There's that great interview from Sunil who was like, Meta doesn't care about SEO. But what I'm getting at is this is something that storefronts might care about. This is something that sites, government sites might care about. This is a thing. It might not be an important thing to everyone, but it is a thing. So let's just get that out there. So there is incentive to address the performance aspect of this. And there is this truth that, to get the performance we want out of declarative apps and whatever, it is basically a lot of cache management. I don't actually have a problem with that, right? Reactivity could be an extension of cache management, perhaps, or state is I feel like you could draw some equation, the React folks like to do to try and simplify stuff, to talk about everything as a function of cache management. Right. So, yeah, I'm catching up with chat. Sorry. DX is not. It depends on your company. If you're Amazon, probably not. Amazon is still using jQuery because performance, they literally couldn't use the modern declarative frameworks. We saw stuff I remember when Netflix removed the React out of their client apps to improve performance. They still server rendered with React, but not they removed it out of the client to improve performance. Performance hits us where we least expect it, or maybe where we most expect it, but just practically don't have time to deal with it. So I just wanted to kind of I'm not going to come and be force you down this, but there's a reason why frameworks are thinking about this, because at a certain point, this is just the framework. We're not even talking about the fact that, when you add interactivity, it's more expensive. Of course it is. You have JavaScript, you want it to do something nice, it's going to be more expensive. We can accept that. The problem is if you absorb your whole budget at the beginning, what are you going to do? To be fair, in his 75th P75 percentile, he basically recommended that we can target a much higher rate now. We can actually, I think he suggested that the size of JavaScript on a page can be something I want to see, it's 300 okay. We can now afford 150 kilobytes of HTML, CSS, and fonts, and 300 to 350 kilobytes of JavaScript gzipped. Okay? Now. Not a couple years ago, now. if you go back, as I said, 5 years ago, his recommendation was like 130 kilobytes. And this recommendation is good for sites that don't care about page load performance. My recommendation personally is take any Alex Russell number and half it if you care about e-commerce. But for the average developer, he's even suggesting that this is basically the reasonable range. Okay? Which is an interesting thing, because I don't know if people saw... let's see if I can actually find it. Let's search. Was it Fred? FKS? Yeah, there he was. I was going to talk about this week in JavaScript, but I think it fits into this discussion right now a little bit. Fred from Astro did a performance report, he called it, where he took real data from the HTTP archives and looked at core web vitals and actually looked at the performance of frameworks. And keep in mind, there's a lot of historical stuff here, but he used WordPress as basically the norm here. And obviously newer frameworks are going to score better here, and different architecture frameworks are going to score better here. But it wasn't just this thing. It was sites passing imp, Lighthouse. There was he did a correlation between JavaScript size and page performance. And basically the average Astro site here was around 277 kilobytes, within that range that Alex was talking about. SvelteKit 323, so still within the range. And then as you move out, they were getting to Next and Nuxt sites being close to about 900 kilobytes. This all checks out to me. This is why people care about the stuff on the performance side. It's just not every site is going to do it, but if you could just not have this as a worry, there'd be benefit. There's been multiple studies to prove otherwise. I'm actually almost, I haven't obviously done the studies myself, but I'm almost as certain about this being true as about anything. So yeah, yeah. I mean, I can pull some of them out. I think someone had a thread where they actually gathered dozens of these studies together. Or if you go to the Quick website, you might be able to find them. I'm trying to remember the eBay one they did a few years ago. What was it? eBay per 100 milliseconds. I mean, some of these things are a little bit pushed, and they don't actually show all the internal numbers. I've seen internal reports that we don't publish about the correlation. It's honestly, I'm ashamed I don't have this stuff off the top of my fingertips right now. I'm sure Alex's blog has dozens of examples somewhere in it. So generally speaking, Amazon, eBay, large e-commerce has made a huge case around this. That they're the direct correlation. Do you know how crazy it was? Kroger. Let me see if I can find his articles. Let me. Tight. Let me see if or was it? We had him as a guest. Was it World's Fastest Website and Other Mistakes? Making the world's fastest website and other mistakes. He basically... okay, thank you. Someone posted it. Yeah, Jazzy Pants already posted it. He basically he had 20 kilobytes to work with for his budget. I think that's insane, to be fair. But it was so important to them. They basically said, yeah, you have 20 kilobytes to make our site work. Like, this isn't like not even remotely debatable from my perspective. It's anyway. This is a great article series. He goes in depth of every trick in the book he could try to do to get performance. Okay. Yeah, I mean, thanks. A lot of these articles, I'm going to post this in because so YouTube gets it as well. But a lot of these articles, if you look around, you will find them. Okay. Okay. Anyway, there is some acknowledgement that there's a performance consideration here. And yeah, I mean, I wanted to start here. I didn't really completely want to start here because of the problem is like people get hung up on it. Like, well, I don't have this problem. And that's not where the conversation should really proceed from. You have to understand that there is complexity that comes with managing stuff on the client side as well, because innately now you're saying I'm responsible for the state of everything, which is fine. It just means that you kind of have to like emulate the browser inside the browser. Okay, so like we've seen over the last several years a simplification in how people want to manage this, because now I'm going to be in single page app mode, right? Like I'm going to get in that mindset and I'm going to talk about what we do, because GraphQL in 2015, Relay, amazing, literally solves the problem. And you're just like, it's hard to picture like a better technical solution, more granular, more powerful than what we do there. Except like you just used up like your budget. See, I'm going to disagree here, and that's these are the takes that I'm trying to like get past today, because it's server components aren't an optimization trick; they're an architecture. We'll get there. But I want to explain this from the DX point, and to think from the DX point, we can get there by looking actually at the evolution of stuff. One of the things that made me feel the most like why I had to do the stream after seeing Kent and Dan talking was that Dan didn't understand how Remix worked. Like, it's very clear. Part of it was he didn't want to put words in people's mouths because he didn't want to assume. But because of him not understanding where Remix worked, he couldn't talk to it well enough to tie put tie a bow around it, put the chains together, because Remix is part of a scale of solutions, a spectrum that have been working towards getting us to where we're going. Yeah, they both didn't understand, and that's the unique value that we can do on the stream, because I think I understand both of them. Right? Because, okay, so I'm just going to start putting down notes to give a timeline, and then we can like embellish on this, but like, let's start here. We had like the simplistic, I mean, let's start with like jQuery or something. I don't know. Can you guys see? I know this is really small. Why can't my default be bigger? Is there like a zoom setting that I can just... I don't want to zoom the percentage. I'd rather... I guess I can zoom. I can zoom the percentage. Like, it's almost like I'd rather just make the font larger. Whatever. So we're going to start with jQuery. Actually, no, I'm not going to start with jQuery because it's too far back. I want to start with like single page declarative apps, okay? Right? So earliest versions of this were like really coarse grained. You like declarative app, fetch on mount or action, fetch and set state. I'm just gonna kind of start there. Declarative, right? Then it was like, I'm gonna jump ahead, but we started realizing we had to do better on caching, and we got GraphQL. Okay. I remember I was talking to Dan, and he said that server components came out of a conversation about like they were internally in Meta going like in 2015 going okay, what comes after GraphQL? That's where this came from. There's a direct lineage here from their work on Relay to the work on server components. Right. But like this declarative app fetch and set state kind of mentality, you know, was basically the whole first few years. GraphQL changed it because it was like, you know, you might put like a simple cache somewhere. Like I guess I missed a step, didn't I? I missed a step. You're right. Cache in a global store, right? You know what I'm saying? Like use Redux, right? You're right. I did miss a step, right? And it doesn't matter which. It doesn't really matter. Yeah, I mean, this is technically true, but I don't like this framing because it gives people the wrong impression that it's like there is data fetching, but it's better to view this as a architecture like a single page app for an MPA than I think is to view it as like a data fetching mechanism. This is what causes the confusion. Okay. It confused me. I actually wrote, it's so funny. I wrote an article that was like understanding server components or something. It's funny. Where was it? Like, let me see. Server components. Learning to appreciate React server components in March 2021. So this is 3 months after they dropped that initial server components demo. And I look back at this. In the beginning, there was Marco. This is true. But I look back at this article and I was completely wrong in my understanding of server components. And even though I like had this realization in this article about like how they worked and stuff, and I managed to get like a better perspective and I shared this with everyone, I feel like most people coming to server components this week are getting to this stage right now, and I need them to jump it took me another year to get past this. Like this was my first, like it took me 3 months to get to this point, and then it took me another year to actually realize what was going on completely. I feel like we can compress that into a week for most people if we do this well. I've had a lot of time to think about this, but yeah, and that's why I did the stream, because honestly, I didn't feel like I felt like I didn't feel like I got the clarity I needed. Like I already knew the answer, but I didn't feel like it gave the right clarity for everyone. After that stream, I was in Discords discussing with people like about the whole thing, and they were talking about, oh, but I would use this and doing this. A lot of the arguments that I'm seeing coming up in chat now, and I'm like, no, you guys still don't get it. So hopefully we'll get to a better place. So caching global stores, then we get GraphQL, okay? But you know what came after GraphQL? React Query. And I want to point that this is the turning point. This was the turning point, because this is the most optimal client-side solution. React Query is less efficient. It doesn't have normalized caching or whatever. It's just a document. Query cache. And at some point, people using GraphQL, using Apollo, doing all the fragments, doing all that, were just like, DXYs are like, screw this. Like, I don't want to worry about that. It's okay. Maybe I'll refetch on a new page anyways. Like if I'm going to the list view to the details view and I don't get to share for the data fields, like not the end of the world. It's okay. Normalize cache, remove some duplication. I'm not going to sweat about it. If I do, I'll do something special and write to the cache myself, maybe. But honestly, I probably never will. And what was interesting to me about React Query wasn't just that it made the cache mechanism, much simpler at the cost of, performance, was that people got even lazier than that. They're like, oh, screw it. I don't want to deal with the stupid cache. They're like, invalidate on mutation. Done. Like, just go back to the server and fetch based on the key. And if you want to understand what that means 2 trips. Right? Like, because essentially I'm terrible at these, side-by-side diagrams here. But what I'm getting at is with React Query kind of view of the world here, like, let's just put this is for mutation I'm talking about, right? You do the mutation. So what am I going to put here? Client server, okay? So you do mutation, takes some time. Server does the update and sends back the response. Send mutation. Right? Response. Okay. Right? So we're okay. So we send the mutation, we get the response sometime later. And then classically, what you would do is you'd use the response to update the cache, okay? So over here, we'd be like, okay, update cache. Okay, where's my arrow here? Update cache, okay? And then we'll do another one, and it'll be like render UI. And these basically happen at the same time, right? So this is what was happening. You do very granular cache updates, and this is what would be happening if you did stuff smart way. And we can give maybe a little bit of color here and make like a little, no, not color for that, sorry. I love sometimes playing with its color. Okay, get my box, make it a little color. So, we've spending a little time here. Let's fill it in. Kind of doing this, right? And whether you're doing it super granular GraphQL or you updating the cache on mutation with React Query, it's kind of the same process. But people kind of like even with the keys, they still kind of like started doing something different. They're just like, no, instead of doing this, let's just like get lazier almost. Let's just, instead of doing this, so this is like, what are we going to call this one? Point write cache. Instead, over here, we're gonna do invalidate. This is why I view this as a different step, even though they did both. What ended up happening is we started doing this. Okay. This box can be a little bit shorter. Okay. The length of the boxes don't really matter. I'm just trying to show visually what's going on here. And you know what? No one really cared. Like you can go like, this is clearly worse. You don't get to actually update the UI until here. Like maybe you combine this and do like an optimistic update and then use the invalidate to like ensure that you have the right data. But like this pattern, this pattern like is very common here. And if you take this, because what they did was they reduced, they had really complicated cache and they reduced it down to a document cache. And if you want to get like an idea of difference in size, if you've ever seen Urkel, bundle phobia. Sorry, I should just keep bundle phobia open. I don't like using bundle phobia because it doesn't have tree shaking, but like, like what I'm getting at is like significant reduction. I think TanStack query could also be around this size. TanStack. I don't know what query core looks like these days. They have way more features, so it's like unfair. You know, SWR. I forget if they have key-based invalidation. They must have key-based invalidation. But like what I'm trying to get at is this drastically saves the amount of JavaScript and logic here. It's like way easier. Instead of being like, okay, now I'm getting this new data and then I need to like add it to this key. Maybe there's already a list there. I need to append that data. Have you ever seen what it looks like? Pagination with Apollo. Like I don't. Okay. No, I don't want the actual query pagination. I want to know. Like I don't know how much I should be looking at this, but like the logic for writing the cache is one of those people in the chat. Yeah, I don't have to show you. You believe me, or okay, sure. Like but I just want to kind of put out there is like you start running like a bunch of logic and people screw it up all the time with cache management, and then eventually a lot of people are just like, screw it, I'm going to invalidate anyway. And this is naturally what happened, which is why TanStack query caught on, because people were just like, I'm sick of wrestling with it, you know, like they're not really noticing this. This is a big delay. Like this is definitely increasing your network thing, but sometimes people are more forgiving of those kind of interaction delays because at that point they perform the action and they know some work has to be done. If doubling the time of that work, as long as it's not too extensive, might not actually make that much of a difference for people. Might not. Depends on the affordances. But I'm just saying this was a move, but you can see this is what we call kind of a waterfall, okay? This is a type of waterfall. It's not the typical waterfall of dependent data, but this is a waterfall. Go to the server, come back, to go to the server to come back. Okay. Yeah, it's a premature optimization, let's say, right? Now, follow me a little bit further here, because do you know what I'm going to put next on this list? Remix. Okay. For me, remix is an evolution of this, and once we got past that fulcrum point of GraphQL, we've been going downhill. And I don't mean that in a bad sense. I just mean we've been going downhill. Okay, because at that point, remix was like, look, we know what data is relevant for your page because of the router. So instead of invalidating on a key and only grabbing specific stuff, and not as granular as like fields, this is like invalidate on fields or write to fields. This is like invalidate on keys. They're like, we're just going to invalidate the whole route. Like, screw it. And you might be going like, whoa, that's extreme. But like, think about it. invalidate whole route, right? Right? Like this is the fundamental thing here. What Remix actually did that was absolutely genius is, we haven't talked about optimistic updates here, but like here, if you want to do optimistic updates on this system, we can add like another like line here. You can basically do something along the lines of like write optimistic to cache, right? And maybe I can, yeah, that's even long, right? We can kind of put this in here while this is going. This makes me want to move our whole diagrams. It won't let me scroll while I'm selecting. Sorry. Wants me to move our whole universe over here a little bit further this way. Render UI is not going to come with us. Either is invalidate. That's fine. But if I love how like random things just get attached. Okay. We can add ourselves another box here and fill it in. Like we can like see the like the optimistic updates while this is happening, but it involves writing to a cache. And for TanStack, it was actually the same pattern, except you saw the optimistic updates this whole time, right? Okay. Everyone still with me? Right? And what Remix did, which is the actual genius part of this thing that they never get credit for, they always get credit for like nested routing and other stuff that maybe they didn't even do originally, is that the problem with this is you still need a cache, right? So if you invalidate the whole route and then funnel your optimistic updates into state instead of a cache, ephemeral optimistic updates, if you do this, you don't need a client-side cache. That is very smart because you're basically doing this anyways. This is how Remix works too. It's a waterfall. You post an action, get a response. The response is like redirect to another page. The client router goes, okay, I'm going to redirect or invalidate. It goes to the other page, starts render, goes to the data loader, goes, oh, I need to fetch on the server again. And then it gets there and then it finishes the UI. So essentially, Remix is this model, but they got rid of the cache. Yeah, I mean, I feel like this is burying the lead. The whole route, no cache. Okay? Are we following this evolution? Developers getting lazier and lazier and lazier and lazier to the point that essentially with Remix, you just like post a mutation, get some state to show your optimistic updates, UI updates. There's a reason people like Remix. It is so much simpler. There is zero cache management. Right? So some people don't like the forms, but do you know what? Do you see a similarity? Now, if you ignore all these waterfalls going on, and you think about Remix in the term of a form post that goes, redirects to a different page, like ignore the fact that this is kind of inefficient, you're back at a sort of MPA DX experience, okay? Right? because by removing the client-side cache, you can look at stuff as just like form post and anchor links. Right? So you guys are with me. I really wanted to dig into this from a DX standpoint, because on the fetching side, the DX standpoint isn't as obvious for people. I don't think so, and we'll get into that in a thing. Right? The problem is, and I mean, this is the challenge Remix had, was they came in at this and they're like, look, you won't need to write another API again. People got really angry at them. Because they were like, no, this is our single page app kind of, world where we manage these caches. How can we not write these APIs and do all this? And the Remix like, no, you just post a form, get the data back. It's like the way the web always worked. We'll come back to that quote, because I think Dan Abramoff stole that quote from them recently. But what I'm getting at is that this whole movement on the mutation side is because we don't actually like the developer experience of managing caches. I mean, caching is necessary for performance, but it becomes kind of clear that we don't want to deal with this. So, starting to get, I'm hoping the different pieces are churning here. So that we're starting to see the pieces come together. We will come back to mutation a little bit later on. But I want to just kind of establish that from a developer experience standpoint, we've been fighting against this stuff for a while, right? It was a huge revelation for people when they realized that when they moved to GraphQL, they didn't need Redux anymore. You didn't need, unless you had some persistent global state, really complicated applications that had a lot of business logic there, you didn't need it. And that was an incredibly powerful thing. But then it slides down the scale. The funny thing is, if we went from global store all the way down to Remix in one jump, people would be like, whoa, this is too much. Because there are apps that do have, more, do need to cache stuff. There is still a need for some amount of client-side calculation stores. It was just if you walked down this path, it felt like one was just strictly better than the next as we went down. Remix was when they were finally like, well, let's just drop the dead baggage. The truth of the matter is, it's not completely dead baggage, but it's a very React type perspective to take, of being you probably won't need it, worry about it when you need it. So the funny thing about all of this, as this is going on, we just explained how when we went from here to here, we dropped 30 kilobytes. And when we went from React Query to Remix, well, we probably didn't drop any kilobytes because it's basically the same pattern. We got rid of a document store. So we might have dropped half a kilobyte. But the funny thing here is none of this actually fundamentally changes the performance gap thing that I was talking about. This is a pure DX part that I wanted to bring in here. In fact, we made the performance worse with our waterfalls. The size of our JavaScript is not meaningfully smaller, even though we did all this. Yes. I have a very good idea what it is. I have not seen what other people are doing, but I can extrapolate, because we will get there. The reason I'm telling you about this is because the mutation story around if I'm gonna be like, you know, spicy, or it's not even that, I'm just gonna do this, right? But it's actually not server components. It's server. Sorry, it's just off the side. It's actually server functions plus server components. We're going to get there, though. Okay. There is a certain progression down this path, and each one does a little bit more than the last. But what I was really trying to say is, up to this point, we actually haven't made the JavaScript smaller. Even server rendering does not make the JavaScript payload smaller. Like, you need all the code to hydrate the page. Like, look at this, not this. I've got a page here. Let's go to my profile. I always love using the thing. I love this page. As you can tell, Twitter is a single page app because of the flickering. But what I'm getting at is we need all the data to hydrate. Like if this was server rendered, we need all this data to make this interactive. And when we go to our next page, you know, switch a tab, this top section might not need to re-render, but other stuff is here. So if we look, if they have to load all the user data from me up front or split some of it into the route, but maybe it's better to do in a single request up front so that even the stuff maybe for the next page, like you kind of figure out how to split this optimally. But what I'm getting at is like to have this experience, generally speaking, in a single page app involves making the whole page, sending it to the browser to hydrate. Question about TRPC. Yeah, TRPC is a fetching protocol. It doesn't matter. So TRPC typically lives in number 4. Like, to me, TRPC is just the mechanism. And to be fair, server functions are a bit of the mechanism, but you could put TRPC in a server function. So like, TRPC is kind of like it's like I call this GraphQL, but it's because the client part of GraphQL actually matters. But it's like the protocol like underneath for the communication. TRPC for me is like that. It's underneath. Okay. All right. Sorry. But my point is, I mean, we can do a little bit of a mental exercise here. Like we can draw the Twitter page and try and think about how we don't send all the JavaScript to hydrate this page. Like what would you do to not do it? Because like the first thing you're going to do, I mean, let's draw this, you know, screw this. Let's draw this. Let's get some white. Let's get some transparent. Let's get some square corners. Let's draw Twitter. Ooh. Sidebar. My profile. My feeds. Let's add a nav bar here. Let's add a nav bar here. Okay. The thing is, the reason I brought up this example is because this is like the remix nested router page example that I love showing. Is we could take sections of this and be like, okay, the outermost box. Let's see if I can grab the outermost box. I might not be able to. Okay, the outermost box is white, okay? And then the next box inside, which is This is my fault for putting everything on top of each other. This box. Did I draw this wrong? I did. Okay, cool. What I meant to actually draw was this box. Sorry, I'll put everything back together again. This is my page. We're gonna make it blue. And then in my page, there is a feed section. This blue is like not doing it for me. God, I so prefer the light mode. It's so much better for getting like way more potent powers. It's fine. I'm gonna remove some of the boxes I don't need here. In my feeds, I'm gonna give it a different color, like green. And then whatever, I'll just like slide. This is gonna be brown because it's part of this, and this stays white. Okay, cool, right? Twitter. What I'm trying to get at is that, like, because the brown or the green sections could swap in, I'm going to bundle along those lines, essentially. Because, sure, this white section might never change, or might have smaller pieces on it that change. But because when I load my initial page, I'm going to load the white bundle, the brown bundle, and the green bundle. When I go to another page, I will, like another tab, maybe I'll just load the next green bundle. And if I go to out of my profile somewhere else, I'm going to load this whole brown bundle, which means that the code is split along these lines. And you basically, to get all the interactivity on it, you basically like send it in these big chunks. And you need all of that JavaScript when you initially load the page. There's no easy way to not send all that JavaScript, because if you pretended that like we just sent the JavaScript for this piece because it's interactive, when we leave the page and come back, we'll need this JavaScript piece as well as this one. Like you'd start having to break everything into a billion pieces and then somehow decide very smartly which pieces you should load initially versus which to load later. And you could build a framework around this, right? But what I'm getting at is the problem is these pieces aren't independent all the time. Sometimes they talk to other pieces in it. So yeah, I'm just saying when you get into this kind of stuff and this level of optimization, you're like, people have been playing with this stuff for years. The term partial hydration, I remember some of the earliest Preact ones is where they rendered parts of the page to the HTML and then other pages parts not. So they basically would look for static content and then be like, okay, I know that from this section down here, this is static. So I'm going to, instead of sending, the JavaScript, I'm going to like make this into an HTML template. I still need to send that HTML to the browser so that this component, when it switches, can renders it. But I have this ability to not have like the React code. And I feel like for some people, even when they look at server components, this is like their mental model. They're like, oh, does that mean that when I've loaded my page, I can go to the server and replace the section as I will? I call this the lakes architecture, where you like have this mental model that, oh, this is static, I can just call out to the server for it. We can talk in a minute why that's a terrible idea, but I do want to kind of highlight that it is basically partial hydration and client-side routing, like single-page apps, are completely at odds with each other. Yeah, you guys got where I was going to this. This is what Quick aims to solve. Good. I'm glad Dan is playing with Remix. I think that was like the biggest shocker of that whole event, was that if you're, how should I put it? If you want all the meta frameworks to use your stuff, right? That's the whole idea. We're building a React for all the meta frameworks. You got to be able to identify with your customer, right? Like that divide in mentality, the thing that led to the arguments between Kent and Dan shouldn't exist. Yeah, I know, right? But React is not the same React as before. If React's customer is not the end developer, but Next.js's and Remixes of the world, that's where you should be spending your customer time. On initial render, you don't need to call it the server because it's already there. That's a good point, and that's the thing. But generally speaking, you always have to consider that you're going to route back to that page, or and then suddenly once you have to go back to the page, all bets are off because you need all the JavaScript. This is true of Quick too. It was one of the earliest Quick demos I remember playing with. There's a reason why most of Quick demos are MPAs these days, is because they'd be super smart and like load the JavaScript as you interacted with it, and then you click next page, and then suddenly it was like, whew. They've obviously have back-end service worker doing like the pre-loading, but it used to be like, bam, here's like 130 scripts coming at you because they needed all the pieces suddenly as soon as you did a client-side navigation. The original Movies demo was like that, and then they switched it to an MPA because like even Quick with this capability. I think this is a really important point, and I'm glad you brought it up. I think even Quick, with this capability of being able to break this down automatically to the finest grain level, does not want you to just go to the next route and have to load all of the JavaScript. Okay? So this idea that like infinite code splitting is going to like completely solve the problem is not it. Like, people experimented with this and thought about this, and this is kind of where the challenge is. This is why, like, trying to take that single page app mindset had trouble scaling. And I think you could solve it. Like, I think you could do a lot of smart stuff and probably solve stuff in a way that's reasonable. And we might get there, in a future iteration. I never say never, because these things come around as loops. Like, this might actually be the next loop might be like that. But what I'm getting at is, when you look at it from a developer experience side as well, and you compare where we got today and to where we can go here, can you get 80-90% of the benefits without worrying about any of this? And I think the answer is yes. And get DX wins as well while you go. Yeah, I mean, I'm not going to lie. Remix is in a hard spot. When I saw Remix, I was like, man, they just recreated everything that Suspense already gives you for free in transitions. This was like a huge benefit for us working on Solid Start, because I was aware of this, that our version of Remix is basically like built on the primitives. So like Solid Start, I always joke about having like nothing in it. Just, the fun of trying to put any pieces together. It's literally because React is building all this stuff into the core. Yeah, I mean, whatever. Fine, clip it. I mean, there's differences, there's similarities. There's no way that I can't acknowledge Remix's incredible contribution to where we are right now, right? It's funny, everyone's like looking for some like combative angle. The biggest problem, and maybe I'll talk about this in This Week in JavaScript later, is the combative angle. That's always the problem. This is why I always have issue with like some of the like former React core team and all that kind of stuff. It's just because they talk in such absolutes, like they've solved the universe, and then you like the reality is never meets expectation. Anyway, so where I'm getting at here is there is a solution to this problem of hydration. And this solution was kind of discovered 10 years ago in other frameworks and other places. I mean, it was discovered even earlier, right? Because, I mean, jQuery doesn't have this problem. This is a declarative UI problem. The fact that all our components are closures over each other. And one approach is unwrap the closures. The other is like don't have the closures in the first place. Yeah, should I just stop answering this question during the stream? I feel like yes, and that's exactly why I'm doing the stream. Yeah, okay. Right. So the answer to this particular problem was solved in big companies with custom frameworks behind the hood over a decade ago. You'll see references of stuff like Wiz. You'll see references to custom frameworks that Amazon uses. You'll see references. The only one that actually was open sourced was that I know of was actually one from eBay that I happened to work on called Marco. Marco solved this problem a decade ago. And you can find the stuff around it, what async fragments with, let me see if whatever I can, was it read it, yeah, async fragments rediscovering percussive HTML. I love this article. It's like no one knew what was going on. Patrick Steele Idem, creator of MorphDOM, creator of Marco, writes this article where he basically explains to everyone how Suspense works about a decade ago. He talks about out of order streaming and how you can render parts of the page and then only send, the JavaScript for the parts you need. Well, you got to give credit where credit's due, right? And we talk about Remix a lot because Remix deserves a lot of credit in terms of getting people over the hump. Like, don't get me wrong. Next and React Server Components would have landed here despite Remix, right? It doesn't, it's not always like a direct influence kind of thing, but I think that it's important to note that when ideas come into the public mindset, to give them credit because they do the work for you. If someone gets everyone sold on the concepts that you're going to sell it with your stuff, then they deserve credit even if they didn't influence you. Of course we're going to end up talking about Astro. Right, and the thing is, don't get me wrong, Marco doesn't solve all the problems, but they solved this one quite well. And the thing is, they again, about giving credit, they listed 6 articles about how this wasn't a new idea. They've seen it in other things that weren't JavaScript frameworks. And I love this one because literally in 2005, people were already calling this stuff a lost art. And I'm I always kind of decide when I'm going to show this bookmark, but Dan Abramoff gave me one of the best quote tweet upsellers I've ever gotten when I was working on Marco. I see if I can find it here. This was a good one too. Effects are reactive, but let's not go there. If I go back far enough, I should be able to find. Hopefully, I should have looked this up up front. It's funny how I can't not just using my bookmarks now is doesn't work anymore. I've gotten to a point. I joined Twitter really late, so for the longest time I actually just depended on these bookmarks as my way of being able to keep track of everything that was important. Here we go, found it. I haven't looked closely at Marco, but this 2014 article describes a mechanism that's ahead of what most mainstream solutions, including React, do in 2020. We've been working to add this to React since about 2018, but it's peculiar how this is almost a lost art. Okay. This was huge for me and Marco team because we'd been facing a little bit of scrutiny, about why aren't we using React or whatnot, and this was an acknowledgement that was really important. So I'm still very appreciative of Dan taking the time to giving us a nod. Anyway. What I'm getting at is that there's this idea of partial hydration. And in Marco, I think the best description, funny enough, didn't come till many years later. Maybe you don't need that spa. Michael Rawlings, meme master himself, that no one knows about, basically explains the idea of partial hydration. The idea that if you can isolate the stuff on the component level, then you don't need the stuff for the static parts. Now, you might be like, okay, didn't you, Ryan, you just tell me you can't do that with a single page app? Yeah, actually, I kind of did, which is why Marco's an MPA framework. I don't want to, so I do want to like put it out there. Marco doesn't give you a single page app like experience, but we also have to look at how things have changed. Like in Marco, this is really simple. You didn't even have like islands, so to speak. It's all written in one language. You literally, like the islands were automatically discovered. It's like you have a class component. If your class has state, it's an island, and everything underneath it is an island. Otherwise, it's fine. When I say everything underneath it, there's something subtle here. So I think we should talk about the Astro Marco React server components. There's a reason at the beginning of the stream that I said that React server components is an islands architecture, because it follows the exact same rules that were set out by Marco a decade ago that Astro and Fresh use. And there's a very good reason for these rules. Okay, so there's a long history in how to do this, right? React's not the first to do that part of the equation, the structural part. And this is important from a DX standpoint. I want you to understand, because we just talked about how the DX of mutations we're heading somewhere. Let's talk about the DX of managing partial hydration. Okay, so it comes down to this. There's actually only maybe I need another pen here. It's only I don't even know if I need a list, but I'm going to start with a list here because it always helps me to jot down my thoughts. There's only actually one big rule of these things. Client components can't import server components. This is the golden rule. This is the architecture. I'm going to explain why this is the case, but this is basically the whole basis of the islands architecture. And it's kind of obvious when you work through it in detail, because I almost have to propose the opposite architecture first for people to actually like appreciate why this is so simple and so effective. So to clarify here, what I mean is client components are our interactive components that are stateful, and server components are server only components that run only on the server. And if we're going to start this conversation from an MPA standpoint, because it's really easy to see this from an MPA standpoint, right? Because if I go to a page, pretend something's an MPA, it doesn't really matter. Doesn't really matter what I pick here. I mean, I can use his example, right? If I go to an MPA and I only have the JavaScript to hydrate these red sections of the page, right? I don't have to worry about ever coming back to this page or navigating, because when I click to the next page, I'm going to re-render the whole page again and only send the JavaScript for the pieces I need again. And when I come back, I'm going to re-render the whole page on the server again and only send the JavaScript for what I mean. I mean, I can static gen, I can do that. I'm not talking about dynamic versus static generation or anything. I just mean conceptually, I go to the next page, only send the minimal JavaScript, and I don't care about the static stuff, because unlike a single page app where technically everything is dynamic, I'm throwing it away anyways on navigation. And it's fine because it's not stateful. We have no state to persist, so to speak, on the static stuff. The problem, of course, is if you wanted to persist these islands, you have a different challenge, which we'll get to in a minute. But essentially, the key to the architecture is this, because you're I guess there's a second. This is actually the second rule. This is the second rule of server components. The first rule of server components is the root is on the server. Okay. However, React can import server components in client components. No, it does not. This is very important. Does not. There's like a sort of exception in the sense that you can like set a new root essentially, but from an authoring perspective, you cannot. And this is for a very good reason. Treating this as a whole app before we get into nested routing is probably our best bet. But the idea is, you can kind of see this if with some color coded code, and I think Dan he actually drew that here. But I'm gonna do it myself for a moment here. It's like color coding, and I'm just gonna use words. But my point is, at the top here, you have. Do we want syntax highlighting? Will that make this feel better? Let's get syntax highlighting. Screw it. Okay. So at the top here, I'm going to just make app, okay? And this conceptually is like on the server, okay? And then I'm going to return a client component, okay? And this client component is something interactive that we want. But what I want to show you about the way server components work is, technically speaking, the client component cannot import server stuff. Like, it can't import a server component. However, I can pass server content as children. Shut up, TypeScript. Okay. And as I said, one thing I did say at the beginning of the stream, I want to kind of highlight this here, is I'm talking about this from a generic sense. The React specific implementation is less important to me because I believe that we can do this for every framework, both as a specific spec and as an agnostic spec. And I've actually written a document outlining this. What I'm getting at is, you can interlace these trees, and you can put more client components in here. But there is an important there's an important detail here that I want you to notice about this tree. Also on the server. And to be fair, this is doable in every single Islands framework. This is not React. This could be Fresh. This could be Marco. This could be Astro. This is just the way this works. Even Quick, actually, to a certain degree. Like they will. You can write your code this way to optimize. And what I'm getting at is, so this is a continuous tree, because when you look at it, when you're here and you're like, I'm on the server, you can basically ignore these things and render this all on the server. And the server can do something like const data, fetch me some data, right? Okay. And it can say, hey, client, here's some data. Again, I don't care how you fetch it. Async components, top level await in Astro, using whatever mechanisms in Fresh or Solids resources or whatever. You know, you can pass data as props to your islands. Yes, there's a router, and we'll get there. But I want like that is not the important part. Yes, yes. Either they'll error on you, or you've just made a server component to a client component. Yes. And like, if you're like using a compiler that automatically figures this stuff out and doesn't make those boundaries clear, like Marco does, this is exactly what would happen. Other ones will be like, no, this is a server component. You don't want to do that. But yes, so technically a server component becomes a client component if you import it. And there's a reason to have maybe some errors or some warnings about that, because your server component might be talking to the database, and then that isn't good. I'm pretty sure that's why React would kind of be like, no, you can't do that, because that would be bad, right? If it's something downgraded, server component that has secrets to something that's on the client. But so that isn't a concern. Don't worry. Like the React's not going to spill your secrets on the, so to speak. I'm just saying that the server tree is this continuous tree that can pass props into the client components. And there's actually, we'll get to this more later. There's actually one more rule, essentially, that has to do with client components, which is that only client components can access client context. Okay. But for me, it comes down to these three. Okay. So we'll explain. I'll explain the last one why in a minute. But back to our playground here. I want to show that this is a continuous tree with props. What's interesting about this design is if I'm somewhere here and I'm on a client and I have, I'm going to make my function client here. Okay. This is my client or interactive component. There's some confusion here, and we'll talk about the SSR impact in a minute. But for now, just pretend this is like that this is actually, this is the right time to bring this up, because client components aren't actually client components. They're isomorphic components, because they have to run on both sides. Like, this would not be very interesting. Where is it? This would not be very interesting if these red areas weren't server rendered, and then you got to the client and they're white, and then they rendered in. I mean, you can do that with web components, essentially. Like that, we've had that architecture for years and years and years and years and years. What made Marco or Astro interesting was that they would server render the whole tree and then hydrate the individual parts. We can get into that, but that's like, again, another dimension here. Like, once you have the model in your head, you don't, like, this is just a natural extension about, like, the build time thing. I don't think that part's actually that important again. Like, it's the same way that you can, like, cache a page or do anything in terms of, like, that. What I'm trying to get at is the isomorphic component, which, const state equals use some state, whatever. Like, this component has props that come in. Like, what do we see? We have data and we have children, okay? And it's really important to understand this, because it's going to do its thing, which I have no clue what its thing is, but it doesn't matter. And then it's going to put the children in. There is no way in this model to very, well, not like easily, and at least with serialization boundaries you can enforce this, to actually send props from the client back to the server. The server tree is connected right? We saw the whole thing, and it has these client islands in them, okay? These, this client component is isomorphic island. And it has its state and whatever stuff in the data, and data and state together can have some fun and render some interactive stuff. But ultimately, see, the problem is if you could import the server component in here and expect it to be the server component, the client component could actually drive the rendering of the server component, and we don't want that. Some people have been making demos like that. I saw a bunch this week, like earlier the week, Daishi's early example. Vue actually, believe it or not, has a server component demo, and it's based, like, they were talking about like how you can't have interactive components in it yet, and it's basically the same thing. And I call this the lakes architecture, because when you come from a client-side mentality, where you follow a different set of rules, where you say the root is on the client, and then you have server components in it, you invert this this chain, so to speak, right? So let's talk about lakes for 2 seconds here, because I want to talk about this. Because the whole idea with lakes is this idea. It's like client root pass props to server component. And the problem with this model is the trees are intertwined, especially if you're trying to do it both ways. Because the truth of the matter is, even though the client root, false, sort of, because all websites start on the server. Okay, so they're like, from a holistic stance, it's not completely true. And the problem with lakes is that if you just weave your components naively, so you can go, let's pretend the client's the root. We can go client, and then the client has a server component. Okay, so you know what? Let's use code. Let's do something similar to this, but let's look at our lake, right? So now we're going to pretend that we're in a client app, okay? Like, it doesn't really matter. I'm not going to worry about this fetch data for a moment. But let's pretend now that we don't even need this top level client component. Like, let's pretend like in here we've got some stuff, which is now, lakes on the client. And inside our lakes, we have a server component and it takes, get our data in here. And let's pretend, actually, maybe I'm going to show the dueling banjos, so to speak. So we have a client component that has a server component in it, and our server component, like, again, I'm not talking infinite loop. I understand what I'm about to write is an infinite loop, but just follow me for a second here. Server component returns our client component, okay? Maybe it passes, whatever, some chillin', hello, okay, whatever. It doesn't matter. What I'm getting at is props. I'm not trying to create an infinite loop. I understand what I just wrote as an infinite loop. What I'm getting at is, if you have this sort of isomorphism where like you can just like import any on either side, what you can get into this chain where these can be different, server 2, server client 2, whatever, but you can get in this chain where essentially you update a prop in the client. It says, hey server, you need to update your data. So it goes across to the server, and the server goes, okay, cool, I got my new data. I'm going to use that data to render a client component and send it back. And then the client component gets in and starts rendering, and he goes, oh, I've got another server component. I'm going to go back to the server, and I'm going to pass in my data. And then the server component goes and it does its work, and it goes, oh, I have a client component. I'm going to send back its data. You basically end up with these crazy waterfalls because the server tree isn't connected to itself. They like, I'm not talking about an infinite loop here. I mean, literally, you can just like pick a page layout and just kind of follow the props top down. You just kind of go update the props on the server component, render some server stuff, get back client component renders or updates its props, then it has another server component in it, and then it does it. Like, serverless generation, I gather you mad. So I hope to understand, like, to point out there that lakes are not good because innately the model allows really bad waterfalls. Like, you might be like, oh no, I only want, like, if you're going to avoid waterfalls, all you can do is put your server components at the leaves. And if you go back to this diagram, I don't think server components at the leaves are actually where the win is. And do you want to know why server components at the leaves are not where the win is? It's because of data serialization. And again, this is a technical reason, but we'll get back into DX in a little bit. It's because the problem is, if we do get our structure, and I want to show this because this is how it actually weaves, right? If you import it, but what you actually are ending up with is this structure of like, I'll just get some text of like, maybe client to server to client to server, because you don't know what possible data that the client could send back to the server, and then the server uses that to get the client, and then the client again doesn't know what possible data. You basically need all the data all the way down that could be used in any of these components when you weave like this. Like, if you had like a user model, and the client can decide which fields it needs to show, right? If you start from a client kind of centric model and then go through like this, you need to like basically know every possible field on the user that the client would need up front in the whole tree downwards. And there's no easy way to know that when you can just kind of weave through like this. What's interesting is when you go back to this model, the only data you have to serialize are the props. The server being a continuous tree, like, and there's no need to worry about anything you don't pass through as props to these components. This is the other part of the win. I've talked about this before, because look, your server component could render, like, picture a Hacker News demo. What do we got? Solid HN islands. Sure. This is actually a solid server component demo, just side note. But what I wanted to point out is you can render all of these stories on the server and pass them. Actually, let's use this. You can render all of these comments on the server and then use these client islands to collapse them. And because the comments are all rendered on the server, you never need to hydrate them. You never send the data. In fact, these toggles don't need any state passed to them. So much to the point that if we look for like our Next.js JSON equivalent for this app, it's empty. Where is it? Here it is. Island map. Like the data serialization is actually empty for this page because you don't need the data to hydrate any of this. And the client component didn't have any props. It just like has its internal state and it wraps other server components. Because there's no communication between them, you actually don't need to send the data. It actually solves the data duplication thing because the server components know that they've encoded the data as HTML, and the client components don't need to, like, they're not privy to it. It's impossible to pass that data to the client component from the server except through the props that you know about. Okay? Yes, it's actually one small solid component to be fair, right? Solid, but yes, that would be the mentality. Yes, my hydrogen clone, HN clone used server components too. Yeah, we've been using server components on this stream for about a year now. Yeah. Sure. Yes, there's no JS needed on the page, but I mean, you can see how that solution doesn't scale and the solution we're talking about does. Once you have this rule, you basically eliminate waterfalls and you solve the double data serialization problem. Okay? Just by design. So lakes are not what you want. They are not server components. In order to actually get the benefits, you need an islands architecture. Okay? So there, we talked a bit about performance. I'm hoping this part so far makes sense. Server components are an islands architecture. But there's implications of being an islands architecture. Right. You could maybe like have like fun on like a leaf node or something. But like that's where the app starts, so to speak. So I'm hoping what I'm trying to convince you with both this example and with this earlier conversation about mutation here, which is mutation in JS. We actually kind of just want MPAs. Like I know that's kind of like an absurd thing, because there's benefits of single page apps, but like we've been trying to rebuild the MPA mutation model, and we've been trying to rebuild Marco's partial hydration. Like, I'm not saying this is where the story ends. I'm just explaining why lakes are like the extreme of us thinking about trying to optimize from a client's side perspective. I have some real live examples of lakes that we actually see in some frameworks. Here's one. SvelteKit has lakes, technically speaking. Not in like the client like re-render sense, but they have no hydrate routes in SvelteKit, which I thought was really, really clever. What they let you do is have the client-side router, and then certain pages that are static essentially don't hydrate them, and because they capture the anchor and like form stuff, like they delegate the events, you can use these pages as if they were single page app style without hydrating them. So like if you keep the experience down to just anchor tags and like forms, you can basically do really simple static type stuff with a client side router, because it'll just it'll just re-render that route section after the fact, like as a client component, but at initial hydration time, it doesn't need any of the JavaScript code to work for the specific section. I hope that makes sense. It's because like they didn't have to bundle the component two different ways. They just have the bundle or the bundleless version. And the bundle list version happens to play into the global router. To me, this is a version of the lakes thing. The downside is you can't add any interactivity. The second you add something interactive to that page below the no hydrate point, you have to bring the whole page in. It's on or off. But it's like an extension, because like Remix has been very big on popularizing that concept of progressive enhancement. And that's the idea, like if the JavaScript isn't present, we turn off the JavaScript, page still works, right? You might click on this and then the whole page refreshes to collapse the comment, but at least you didn't have to wait on the JavaScript. If it failed, something goes bad. And in terms of like being a fail case, I think that's really good. But the problem is, like from a hydration standpoint, you have a completely different experience if you click something too fast versus waiting for it to hydrate and having the JavaScript. And it's very on or off. It's like you have the JavaScript, you don't have the JavaScript. And on early page load, that's not up to you. But like if you just turn off the JavaScript on some pages, you can kind of progressively fall back into like an MPA, a static MPA site. But like once you have to leave that, like let's say you're on that static MPA site, if you want to get back into a spa page, you're going to do a full page refresh. And if you're in the spa page and you go to that page, you have to get to that page from a full page refresh. SvelteKit has kind of solved this by sharing a client-side router with those static pages, which is really kind of cool. But what I'm getting at is, in both cases, the second you want any interactive JavaScript, the whole app's coming in, like the whole page. Yes. Non-global state between two logically distant components and server components. What's the solution to that? Yeah. Okay. Yeah, so how do you say? Regarding islands architecture, one thing I've always found difficult, the current solution is shared non-global state between two logically distinct client components in a server component. What's the solution for that? I'm trying to think about two logically... Yeah, you have to use client context, essentially, as the solution for that. Because the communication is rightfully blocked off, the client can't communicate directly. Like the server structure is continuous, but the client structure is separate. You want it for partial hydration because you want each island to be its own thing. The solution is that all the islands can be connected together using the context API. And this is something that we haven't implemented into any examples in Astro, but I did do that in Solid Start. So we could, it's more up to a problem for the client framework to solve than the server framework to solve, so to speak. As long as the client islands can communicate with each other, this should be good. We'll get into that a bit later about like the challenges of approaching this in an agnostic way. I honestly don't know on this detail. They might be. The problem, I think most of the time Quick dodges this because they just go, they go to being an MPA framework. Like, so like the page is going to go away anyways when you navigate. Like, otherwise it's interesting. I imagine though, I would just use the exact same rules I'd use with server components and work here. Like the thing I want to point out here is this isn't something you cleverly solve around. There is a real boundaries between the server and the client. So either you're serializing it or you're doing something else. What's cool about this islands architecture is two things. You know where the boundaries are. Client component props are the boundaries. This has to be serializable, okay? This has to be serializable. And then the second thing is what I explained already with the way the trees work. Essentially, you don't have to worry about, like, you can optimize a bunch of things like the data serialization and waterfalls and whatnot. So, sorry, we're trying to get back to where I was trying to get to this. I was just finishing telling everyone that everyone actually kind of secretly wants an MPA. But it's a bit more nuanced than that, because obviously we like client-side navigation. I mean, there's no way to actually get around that. Let me do something here. Let me see if I can find some of my HackMD stuff. Sign in. GitHub. All right. I've been writing documents describing the behavior of how you could apply these architectures to different sorts of approaches. And I don't know how much I'm going to reference this particular doc. There's a lot of considerations here as we kind of move forward, but I want to kind of start talking about how, now that I'm hoping now that we're all on the same page, that secretly we just want an MPA, that we can talk about how we actually solve the problem here. Yeah, it's interesting because Dan Abramoff drew this diagram here, trying to show that the same thing of how the components all kind of like weave together. So like in this case, the green ones are the client components and the blue ones are the server components. And he's showing like the black is like when they become HTML. And in React, there's very much a stepped process here, but like I don't think there has to be. It depends on what your approach is. But essentially what he was showing is like the first step is turn the server components into HTML and keep the client components in place. And then the second step, which either happens during SSR or happens later on the client, is to turn the client components into the remaining HTML. And I like this one. I wanted to pull it out because I was hoping that in addition to my explanation that I just gave, that this kind of helps fill in the gaps. Like this is what I was talking about with the tree being contiguous, because you can actually render all the black parts without touching the green parts and then isolate the green stuffs. I've often made that comment that React server components is like taking a framework and wrapping the existing React with it, like it's like Astro almost. There are some rules, to be sure, which make server component client components not the same, but generally, and that's why the authoring is different. Like, and also just like other things, like there's no need for state. But it was like a kind of interesting observation because any client component can be SSR'd. Technically speaking, any client component that doesn't read context could be a server component. This is an interesting consideration, to be fair, but this is why the boundaries are, I think, one of the most frictionless points in terms of APIs. So, yeah, he didn't draw the router. Yeah, so here, this is why I like this diagram, because it shows the mentality. The very first React server component demo confused a lot of people. What was it? Zero bundle. Was it zero bundle server components? Introducing zero bundle React server components. If you watch this, it's great stream, great that, and they had a demo. They're like, hey, clone the demo. We cloned the demo and we looked into this on stream a little over a year ago when it started clicking for me. And what always confused people about this demo is there's no server-side rendering in this demo. There's no SSR in this demo. It's a Notes app. And actually, do I have my own version of it? Solid Notes? It's fine. I don't remember the link off the top of my head. Because we remade this demo with Solid's version, obviously, is that it's very much about the way React approached this, right? Because for them, you know, they started kind of like, can we do this initially so that we get to here, and then can the client do this? So essentially, in their version, all the client components only rendered in the client, essentially, for their initial thing. And then as they changed it, they could swap out the server components, but there was no SSR. I approached this problem from the complete opposite side. We built islands like Astro first. I love, yes, that is the demo, isn't it? Let me see if I can see it. Right. This demo is always like a little bit of fun because what's cool about it is like these things are server rendered, so you don't ever need to send the JSON for them. But then when you go new, then you load the code to actually make the editor, right? If you got to go in here, then now you can edit it and be like, here's the title. And somebody's deleting notes on me in the background and stuff. But what I'm getting at is like this demo, the original demo didn't have SSR and was very simplistic. I think our demo does have SSR, so maybe this isn't the best comparison. Okay. Anyways, I got a little bit sidetracked there for a moment. But the demo was a very simple list management tool that didn't actually do the SSR, and because they were really focused on just weaving the trees together and making sure the pattern worked. Coming from our islands approach, if you already have islands, you have the ability to get to this on the server for that first render. You can just go from straight to here on the first render. And then the question starts being, how do you find the anchor points to do the replacement? And the simplest version for that is something that Astro was playing with for a while too, which is a Rails technology called Turbo Links, or Turbo now. See if I can find their official website. See, this has been archived now because they don't call it Turbo Links. They're now Turbo. Turbo Links was a very simple approach. What they did was take your standard MPA website. If you click on any link, hijack that link, instead of reloading the whole page, basically diff the head and replace all the HTML underneath. So you get pseudo client-side routing because the whole page doesn't reload, but all the HTML is basically replaced beneath the body. And then because that page, you merge the head essentially, you can pull out you load the new JavaScript for the new island you need on that page, and you get an experience that's like kind of like a really basic version of client-side routing for MPAs. And to be fair, Turbo still runs that way with Rails. People seem to be fine with that. I think Flamethrower JS from Fireship is the same sort of idea. Okay, IELTS uses Turbo. This seems fine, right? I wrote an article about like all the different patterns you could use for front end, and this kind of routing I called hybrid. I hate my labels. I was having such a hard time coming up with the labels for it. Like, what was it? Dev2, dashboard. What was it? Patterns for building UI frameworks. This one? Yeah, okay. Or I was talking about routing, and I did a whole stream dissecting this article. But essentially, Turbo Links and this stuff is what I call this sort of routing, right? There's implications of being able to make these decisions, right? If you have a classic MPA, yeah, full page reloads, you don't preserves client state below change. No, you lose the whole thing. Client side transitions. No, renders on the. I mean, maybe one day with the new browser APIs. Renders on the server after first render. Yes. JavaScript in the browser. None. You don't need any. Using Express, right? This is an MPA. Hybrid, like I'm talking about with Turbo, is there's no full page reload, but all the state is lost. You could try like client side transition on a full page level. But, it still does render the page on the server, and you don't need that much JavaScript to pull off this trick. Maybe like 2 kilobytes or something. On the opposite end of the side, but notice how these both have multiple entries. Like usually the authoring experience is that the app is essentially like each page is a page. Something that's happened on the client side, and the reason we have nested routing is we view the app as a single entry point, and that it's just a matter of nested layouts. But the thing with client side routing is, there's no full page reload, and it preserves all the state, and you have the transitions, but it doesn't render on the server after the fact, which means you need all the JavaScript, which is a lot, and I use React Router as an example. I called it transitional. I regret that now because Rich Harris retconned the term. I realized that nested, I've used Rails. I realized that it but anyways, what I was getting to is that there is a solution to routing that combines both of these, and this is something that I've been exploring pretty much all of last year. That was my 2022. I wrote in January that the future of routing was on the server, and then basically we delivered on what that could look like in October when I released the client-side routing without the JavaScript. I'm just going to drop this article in here. But it's important because this shares all the characteristics of what React server components or what a server component router would have. And I talk a bit about this, but let's just like step back, and I'm gonna high level just kind of go over what the flow is for this from this thing. Basically, if we were to generalize this, and I know React has different mechanisms we just talked about, the way this server component world works is the initial page render is very similar to what you find in an islands framework. All the components are server rendered and sent to the browser. Client components or islands props are serialized, and basically any data fetching that you did inside a client island also has to be serialized. Kind of like your classic Next.json, right? And then when it gets in the browser, the client, it can stream in, it can come in any way. As the client components are kind of collected up, these islands, and hydrated as they're available. So far, the first experience between a server component framework and an MPA, islands framework is almost identical, minus the fact that the server component framework will have loaded this router that I haven't described yet. But generally speaking, you send down these islands, and mechanically it's very similar. Then, on any subsequent navigation, the server, you basically almost treat this like client-side routing, where you change the URL. It's actually it's actually like URL driven. You go to the next page, change the query parameter, do anything you want with that, and that is how you actually tell the server to re-render the page. There's no passing client props to server props. You actually use the router to pass props to the server, essentially. You use the URL the way that we've always done with an MPA. The key part about this experience on the second point, when you navigate, is because we wish to persist the state, and we don't know how that state has updated on the client, no client components can be rendered on the server the next time around. Essentially, we get the new HTML that has holes for the client components. And if they match up, like we diff the old HTML and the new HTML. And if the islands match up, then we persist the islands and use those props to update the props on the existing island. And if they don't match up, we just client render the island at that point. So the basis of this whole mechanism is a simple HTML diff. I mentioned Morphed On before. The guys from Astro built one. It's about 1 kilobyte, right? The navigation story is kind of like an MPA. But I want to go back to this example, because this is the problem with Hydrogen actually had, and all the early server component demos, and the way they had their problem was if you navigated the whole page every time, like an MPA, you were diffing the whole page every time. Sure, you saved on that initial JavaScript, right? You had some, let's make our client components blue color and let's fill them in, right? You were able to kind of, and let's give them rounded corners. You were able to kind of go like, oh, this needs to be interactive, or, maybe this needs to be interactive. You're able to save on that JavaScript and only send the interactive parts to the browser that you needed. But every time you did a navigation, you basically were sending a new HTML page. It's like slightly better than Turbo because you're diffing it and trying to match up the islands. But this kind of is expensive, right? If you've heard some of Ryan Florence's early criticisms of React server components, it was because of like this. He's like, what? So instead of sending the template once in your JavaScript, you're sending it on every single action. Like that was kind of mentality people are kind of criticizing this on. And I mean, on a certain stance, you can go like, it's no worse than an MPA, and MPAs seem to be, doing good for, certain types of use cases and stuff, but it's something you want to improve upon. And the solution to this should be kind of obvious if you're looking at this picture. Nested routing, right? Like if I'm only swapping out this content, so to speak, then I can leave the rest of the page alone. And this it's funny how frameworks always come down to the routing paradigm, more or less. Like that is the clincher here. But if you made the route the nested barrier, like the nested routing the barrier, then you have incredible ability to kind of like when your initial page load, and you control when future navigations happen, so you can always send headers or whatever to say like, hey, this is a future server component draw. So you can always, like, the next time you go here, render everything outside, like the black here, and skip the blue part, so to speak. But nested routing, because we have a client-side router, lets us only render the parts of the page that matter for the particular navigation. We'll get to mutation in a minute, but this is the mechanics of, again, why Remix is so close, but like almost just like a bit back. It's kind of funny. Like Hydrogen had the earliest version of server components, and they needed Remix to like finish the story. And it's like it would have been really interesting if they'd both worked together right from the beginning to end up at the right place, because it's like the parts that Remix didn't have, Hydrogen had, and the parts that Hydrogen didn't have, Remix had. It's like there's a huge symbioticness of this. Meanwhile, Next, privy to all the information of the future, knew exactly what to build. So what I'm getting at is, okay, nested routing is the key to the initial data fetching kind of navigation story. So if we can just swap out those sections, then it's pretty cool. The only problem is you don't want to render the whole page again on the server either. If you're just swapping out this place, you don't want to render this up here. And this is a problem because what if you have a context provider at the top of the tree and you're only rendering this component? It's kind of awkward, right? This is why you can't, like, it's not just awkward from the fact of like you only want to render this. It's awkward from the fact that if you went on the page, clicked the counter 5 times, updated the state up here, now counter equals 10, this counter's up 10, and you show the count here, when you go to the server doesn't realize that this count is 10. You're not going to serialize all the data back. That's what .NET did. We are not doing this. That is a nightmare. Serializing all the client state back and forth, this is why we're not going back full circle. That's what we did like 15 years ago. We're not doing that. But it means that the client components after the fact, this is why you can't render client components after the fact, because if they use context, if they read from this context up here, or up here, I guess higher up in the page, then there's no way that you could get the like updated values when you server render. So where I'm getting to is we have some new concerns or things we have to think about with our solution here. We already talked about importing component rules and preventing waterfalls. We talked about nested routing and layouts, but I'm going to skip templating concerns and suspense. Yeah, load versus refresh semantics, right? The initial load versus other like server component navigations are different, right? Initially, we have to actually render everything, and after the fact, we only render server components, right? Which I highlight here. Don't render islands. Right. Don't render islands at server initial load. Render only required sections we just talked about. Consequences, all data needs to be independent. Yes, okay. So one of the awkward bits about going here is what if, this is my users page, right? So I load my user here and I'd still need my user information there, right? We're on Twitter. Let's go back to my profile. As much as I love looking at the tweet, like perceptually, we could just load the user information once up here and still use it on all of these tabs. It's funny, you can tell by the scroll thing, I'm pretty sure that they actually don't use nested routing, even though I use this as my example all the time. They might still, but I'm suspect. Maybe they do. Where was I gonna go with this? Sorry, what I was trying to get at is that you can see on that drawing that this whole section is my user, right? So if we're only gonna render this and we fetch the user in this section, you're not ever gonna run that code again. So in a sense, you have to fetch the user in both locations if you want to use the user. You can specialize it, but if you actually want to like not on initial load it twice, you need a caching mechanism. You need a way of saying like, hey, I fetched it here and fetched it there. In a sense, not unlike what GraphQL does or React Query. Yes, now we're back to cache invalidation, but the cache invalidation is on the server. Okay. Yeah, it's so important with these things to understand that you never actually solve any problem. Like, you never actually solve the problems; you just push them around. But there's different consequences to pushing them around. But yes, now you need to do that because it's fine. If you just come in and render this and fetch the user, you're good. If you come in here and have to render both sections and you fetch the user here and fetch it again here, you're not so good. Right now, I'm only concerned with cache for the lifetime of the request. you can get into whole other things on there, and you can come with your own cache strategy. But I am mostly talking, when I say cache right now, I mean actually just, I'm not even talking about actual long-term caching necessarily. I'm talking about like simply having some kind of way of knowing that when you do the same request in both places, that you can use the same data, right? We can get into deeper cache things, but you still have the win of not having to cache in the browser. But we do have to have that kind of consideration around designing this. And yeah, as I mentioned, we could take this further now, because if we've done this effort of these needing to be independent, we might as well parallelize it. Like on that end, but we can't parallelize it on the initial page load, because if you have a context wrapping the whole thing and you need the server render these components, you do have to do the provider before you do the children. So technically speaking, you can't parallelize at least the client tree. You could parallelize the server tree, but you can't parallelize the client tree on initial render. Just kind of pointing it out there. But if you think about it, otherwise this is completely independent. So you can literally, request comes in and it needs to like replace both orange and green here. You could just like run the orange and run the green in parallel, and then stitch them together at the end. So if orange is waiting on some data and green's waiting on different data, you can actually have them like, and Suspense orchestrating all this, you can actually have them all kind of doing their own rendering interchangeably without like waiting for orange to finish before you start green. Okay. This is a lot of the benefits, if you're listening to me. It's similar to what you find with loaders and parallelization of nested data structures. Yeah, is deduping the term I want to do? It's not caching, it's deduping. That's what we need to do. We need the dedupe. Okay. So there's still challenges from an agnostic solution, because while I think it's fairly straightforward from a general standpoint, that you could write such a system that, take Astro and then, for example, and then tell it on, subsequent requests, I only picture Astro with nested template, like some of the file system routing stuff, that we have. Or you could picture basically these sections being like .astro files or whatever, and then these just being your framework components. And then when you get to a certain page navigation, being like, okay, swap out this piece, don't render the islands. Like they already know how to render islands and how to hydrate islands. You have client only, like you already have all the mechanisms to be able to do this if you wanted to do it. The only challenge is, if you wanted to do async stuff and streaming, and the thing is, that's very much on the outer framework versus the inner framework. One of the realizations that I came to, even though they're going to solve this, is most of the patterns we use for reactivity, for data fetching and async on the server, not on the server, in general, like Suspense, are built based on where we use it, on read rather than on fetch. And I think this is important to understand. It means like where you use the resource or where you await the promise is where like the suspense happens above it. And it's actually kind of interesting to me because Marco had an await tag to show where that read was. Remix actually added an await tag to show where that was. And some people are like, why didn't you just use a hook? And I think you almost have to visualize it to understand the problem here. I showed a really simple component here, but now pretend this is your page in your app and you need to fetch this data, right? So you're like, oh, no problem. Async, it's on this side. You're like async app await fetch data. I solved it. Well, what if you where's the suspense boundary? The suspense boundary has to be above this route section. And in our app here, there's nothing above it. So either you just assume that the route section is the suspense boundary, or you have to push the await further down the stack. So you have this kind of tension where you want to fetch the data as high up in the tree as possible and await it as far down as possible. Otherwise, you'll produce server-side waterfalls. And that's the thing. Waterfalls are bad anywhere. Don't let anyone like try and convince you otherwise. Waterfalls sometimes are necessary, as in they are unavoidable, but avoidable waterfalls are never a good thing. Ever, 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 ever. It doesn't matter the distance. We can talk about, we put the data right next to the database, so, or the code right next to the database, so it's not as bad. But like if people start pushing a narrative out there that like, oh yeah, waterfalls here are okay, like go send them packing. This is like, this will always be a contention from a performance standpoint. The only difference now is instead of like the front end engineers being like, oh, you know, I'm really noticing this in my app, you'll have back end engineers really mad at you going like, what are you guys doing here? they're if you especially work on a large team, the back end engineers like this is why they don't want to give you access to the APIs. They're just like, they're like, you guys will do some really stupid shit. Yeah. If you want to piss off your back end team, if you still have a back end team, like maybe you don't have to worry about that. You scale your infrastructure infinitely, but like, and you just pay in dollars. Sure, don't worry about it. But like, do more waterfalls. The funny thing is the client side waterfalls, they're almost like not even aware of, because like the performance is so bad on client side waterfalls. Like there's such a separation of requests and stuff that the backend team might not even realize the terrible stuff you're doing. But as soon as you like bring it closer to them, they're going to be like, well, like why are you doing this to me? Yeah, exactly. And then pay for planet scale. Like, don't get me wrong. Sorry, I didn't put the tweet off. Yeah, or the message up. But yeah, don't get me wrong. Like, I'm just saying, like, maybe this won't matter, but don't sell it as a good thing. Sell it as like, that's cool that we've mitigated the expense of this in this specific case. Just don't move this to the edge. You know. Like there's benefits from a DX standpoint, but it's so funny. Like I've watched this so many times over the years, like building everything in an ORM, and the ORM wasn't that optimal. And then you go, geez, why is the performance so bad as stuff scales? And then you go, oh crap, it was because we traded DX of having a nice ORM for actually writing efficient queries. And the answer is like, of course. Well, let's just in the few places we need to optimize and not throw away the whole ORM. That's generally the right approach. So I'm not saying don't do this. I'm just saying, like, naturally your patterns, like if you've seen the data loading patterns, yeah, maybe it's a good time to talk about the state of the art in client side routing. It's like, because if you get to nested routing, you almost immediately hit what we've been doing like the last decade. I actually don't think crossing the boundary is that interesting. Like the fact of, I was going to talk a bit about how if you pass a promise, yeah, I mean, I'll do this before I get into the routing. If you pass a promise from a server component to a client component, the client component never knows if the server component never knows if the client component is going to read that under a suspense boundary. Like it never knows like if it's server suspense boundary or a client suspense boundary is what like is going to handle the situation, right? Because if you pass a promise through and you await it or use it down and there's no suspense boundary on the client below, like above that point, the suspense boundary is conceptually on the server, then the server should have waited before, sending that data. Whereas if the suspense boundary is in the client component and you use it under that suspense boundary, then the server should have responded right away and not waited. And that is not an easy solution to solve. So much to the point that I'd argue you could just take a stance. If you need to await something on the server, like you assume that if you're going to pass a promise through, you're awaiting it on the server. Like, I think that's the only probably reasonable approach you could take here. Or you could take the opposite and say, assume it's always going to be awaited on the client and that it's not going to wait. Like, either or, you can make that decision. And I think if you just make that decision, then you can actually treat the data suspense mechanism between client and server components is a completely different system. And that's interesting to me because it means that you could have like Astro Suspense and React Suspense in the same app and them not at all, like it doesn't matter because one only handles the promises on the server and one only handles the promises on the client. And you don't need the same framework. Like, and as long as you have a mechanism to handle async rendering and scheduling, basically to be able to do async SSR, you can do this. But yeah, let's talk about routing for a second. Universal JSX routing. Right. Cool. Okay. So I'm actually going to pull up the Remix page because Remix has good docs and they have good example to show you like how, like we've all seen this nested routing demo. It's just an extension of what I was showing. Can I see what the code looks like? Yeah, I can see it a little bit here, right? They define a loader, they define an action, and then you can use the loader data in your component, display some stuff, form a post against that action, it updates. Okay. The reason I wanted to show this is there's been this pattern for a while, and it's in most client-side routers at this point, and it's funny because like Remix gets a lot of credit for it. We had it installed independently of Remix completely, and ours are different because they don't only run on the server; they're isomorphic. And I think Sapper had a pattern as well. Basically, any framework that does nested routing and data fetching in parallel, which I think the first one was Sapper or Nux. I'm not sure which one. In around 2017 or 18 time period. Has had this mechanism essentially hoisting the data loading out of the component so that if you have a nested route like this, you can basically when you're up here and you like click from sales to accounts, it can go, okay, I need to load the data for this section, and this section all in parallel while I'm loading the code for each of these sections all in parallel. Otherwise, you'd have a waterfall. Like if you put the data loading for sales inside the sales component, and you put the data loading for the main tab inside here, and you put the data loading inside here, you'd actually, and it's all code split. You'd have this fun example of basically wait for the bundle, fetch. Okay, get the data, render it. Realize you have to render that you have this boundary, fetch. Wait for it, render, fetch, like crazy amount of waterfalls. And you might think, this is absurd. Who the hell would do this? Well, basically almost every app that I came across during the 2018-19 period, there's a reason that Solid was just like slamming through demos with CSR only versus like SSR apps. They were terrible for doing waterfall type data fetching patterns. Code splitting was like the new norm. So everyone, cared about a lot of like the initial reducing the JavaScript side, and then you did anything in these apps and you got this really awkward gap between like loading the data and the code and all these waterfalls, just horrendous. So we hoisted it into loaders. But what I'm trying to get at here is that who would do that? Everyone. Yeah. Well, I mean, it's kind of like the other thing that I showed about mutation, right? People generally, if left on their own, won't care. So like, this is like as much of an argument for server components as anything else. Like by just like changing to more sane defaults, then we aren't like doing crazy stuff. There's some challenges obviously with these loader patterns like TypeScript. It's because of the detach. How do you get the props in? Do you pass it in as props? Do you pass it in as context? If you do context, it's easier to get the whole tree. Like there's challenges there. One of the challenges I had personally was the fact that I didn't like how singular these were. I wanted stuff more granular. Solid this is how Solid ended up with server functions. because we wanted the ability to granularly fetch each resource separately, even after the fact. Okay, so I was like, oh, why can't we just use RPC calls, for our actions? But I'm not getting to the actions yet. I want to focus on the loaders. Right. Sorry. Oh yeah. Remix is actually showing. Yeah, this is perfect. Yeah, this is what I just described about the waterfall thing. And the truth of the matter is, people built apps like this a ton, and Remix was not the first one to solve this by far. But in React space, like maybe they kind of were. Like Next kind of kept stuff at a page level, but like ideally you'd want to have this amount of granularity. So that's a great one. That's why they're saying no more loading spinners. The funniest thing is, this experience of loading spinners like this is better. Picture the same diagram now, except the Remix side is white until we're done. If you ever want to argument about streaming, that's what you do. I think let's just go to the Marco homepage, because again, Marco, of course they're going to put JS on the end, because otherwise we're going to end up with some other stuff. But like I thought that was interesting about the no loading spinners, because it's like with streaming without streaming. You could picture that there's loading indicators. He didn't bother doing that. The loading indicators are fine if they actually help you like get there sooner. The problem is, in the classic example here, it's actually you're waiting for JavaScript bundles to come in to fetch to get more JavaScript. Like it's this chaining waterfall. If you could set all the data fetching to happen on the server immediately, and then show stuff as soon as possible and show some loading indicators, that's streaming, and that's the winner. Right. This is like CRA or something, right? Okay. Before it got it back into React Router, technically, but Remix was before Location, and then I don't know what came out first, Solids Router or Remix, probably about the same time. I was using this pattern in demos. It's funny, I wasn't using this pattern. I was using something more like server components in demos. And then ultimately, I think Sapper or Nuxt should get the credit if we want to go back historically on this approach. But what I'm getting at here is that, that aside on loading spinners, I was just kind of commenting that it's funny how like different extremes work. I actually think the loading spinners are kind of a good thing, but like if something takes a long time, you should show it. But I get where this is coming from, and I wanted to show this because we need, from a performance standpoint, loaders get rid of the waterfalls. Okay, so I started asking myself, what would no loaders look like, right? And the funny thing is, it's funny that solid real world demo. I wonder if I can actually do this, because I use this pattern all the time back in the day. Actually, no, screw this. Let's just go to Solids repo. Because I used to make a lot of demos without having a thing. And in SSR, I have this silly example where in the shared folder, I have this router that's like really simplistic. It's not even an actual router. It's like I just like made a link tag. I basically just made a router from scratch for fun in this demo for some reason. Just using like, let me see, switch match. Where is it? App, components, app. Yeah, I just like put a switch match in here, like switch match. Here's my routes. It matches this. Then show the route. Like I just did something really, really stupidly simple. But the reason I wanted to show this is because this is kind of like the really simple approach. Because you go, okay, when I show profile, it should show profile. So if you notice here, I didn't lazily import. For the other pages, I lazily imported them. But for profile, I didn't lazily import it. And instead, in the index for that profile. I create my data loading stuff, and then I render the actual profile component. And that profile component is lazy, right? So essentially, the routers resolves the route to a component that really I just do all my data fetching in, and then I pass it as props into a lazy component. And that's basically how you would do it without a loader. This wouldn't help you with nesting unless the router itself parallelized all the nested rendering so that it basically could render each section separately, which breaks context. But if you're okay with that, render each section separately and breaking context, and then you just put it into the outlet of the parent when everything kind of sets down. But if basically you have a hawk essentially that passes data into your lazy component, and this pattern is what I was trying to show, because I use this a ton, everywhere in 2018-19 before I wrote the router, because waterfalls were really bad, and I was like, let's just separate the data from the code splitting so we can do stuff in parallel, and that turned out to be a benchmark winner. But yeah, same pattern here, right? It means that when you get to, if you didn't have a loader, what you'd actually have to do is say that the route page, get some route information, fetch some data, and then essentially make a lazy version of it. But I started realizing that there's a certain parallel here with server components. I called it island here, but you can pretend this is use client, in a separate file that you import. It doesn't really matter. This is just using my syntax. But what I'm getting at here is this could be a server. This could be a server component, and then this lazy component, it might as well be a client component, for all purposes. So you fetch your data, and then you pass on the server, and then you pass it to the client. So anyways, this is my I don't need to talk about this right now. I basically came up with how I would design a router that worked with server components and client only. I'd work in a SPA with no server components and in a server component scenario, and work on both sides. This might be something I implement at some point, especially when I add Tenor's TypeScript type stuff in here. So next big change for the router. But in theory, all a loader is a component that wraps the top level of the route and automates this lazy or client kind of boundary for you, essentially. So it works well with file system routings, because then you don't have to worry about writing lazy and porting all the stuff yourself. Lazy is kind of a pain because you have to have a separate file. So this was always really awkward from an ergonomic standpoint, because it means that every route needed two files. It needed a file for the data loading and a file for the code splitting, which at a certain point I was like, why don't you just build this into the router and not worry about it? And that's what everyone did. What we're seeing right now with server components is kind of a reversal of this, going because you don't always want the whole thing to be a client component, right? We have to put that control back in your hands. But it's a similar mental switch, because what you should be doing is fetching all your data at the top of the route. If you fetch later and it's below conditional, guess what? Waterfall. If you await at the top, well, then you block the rest of the stuff. And if you have fetching underneath, that's even worse again. So essentially, even with server components, you are basically going to replicate the loader pattern. But it's fine. As long as you know that, then you can approach this in the proper way. If not, you will create server waterfalls, and for the first year, everyone will be like, yay, we don't have to worry about this stuff, and then it'll catch up with you. That's just how these things always work. But that being said, I think it'd be cool to unify the models. So I just kind of throwing that out there. I think it's very possible that a complete client single page app and a server could have a same universal router mechanism for data loading. At least the harness piece. Because what's cool about this is there's no special exports, right? You just kind of grab the location data from the router. This part is interesting. Different frameworks might handle it differently. Maybe this is a promise. Maybe this is a resource, maybe use. I don't really care. The details don't actually matter that much, as long as, and it can actually be different between client and server is what I've been trying to suggest here. But I'm suggesting that like this pattern could be repeatable to work in client side optimally as well, as long as people are willing to go through the extra thing. I wasn't. I figured like this was too much boilerplate, so I built my router, and most people did around loaders because this is like obviously what you want to be doing. But it is interesting that people want more control. Should we not give it to them? It's interesting. So yeah, there's a direct correlation between writing the code you should be running and writing a loader. That's all I wanted to kind of highlight at this point of the phase, because each of these sections, when you load them in, you want to fetch the data as high up as possible, and then use it as low down as you can. Okay. All right. So where am I in my overall arc here? We talked about, right, it's a time to talk about mutation. Dan said that we need Chrome Network tab for servers to see waterfalls. Yeah, I'm sure. I mean, it would help. Better tooling is always good. But it's like you can also kind of just like see waterfalls by the fact of like there's an await somewhere. You're probably creating a waterfall. All right. So okay. So let's see if I can summarize this the best way I can. I've already kind of talked about why you might want an MPA like mentality in terms of both mutation and page load for performance in DX. I was talking specifically how we solve the routing and explained why is if you sacrifice client-side context, essentially, if you make it special, like only client components can access client context, then you are in a zone where you can basically just author your app with this interweaving. And okay, yeah, there's one more before we get to mutation. There's one more piece I wanted to talk about, and I think it's pretty important. You kind of saw a hint of it with the router case, but people worry about how this scales, right? Because this is getting back to the Ryan Florence initial thing where he was talking about like, oh, then you're sending all these templates. We didn't actually address this completely because, yeah, we shrunk it down, but this is still a large template. The truth of the matter is most interactive stuff is going to happen inside these interactive spots. And the thing is, it's only a route level navigation. Like basically, if you want things to update all over the place, you're probably going to do this, right? It's only route level navigation that you go back, at which point you're already kind of like a leg up on, MPAs. But the other consideration is, let's say I don't believe in this stuff at all. I just want my old single page app back, right? Why are we doing all of this stuff? Why are we doing all of this stuff, right? Well, if I'm really lazy, I can just do this. And if we go back to one of these HackMDs and you look at this example, if my page is just some data loading and then I go straight to my client component here, what am I rendering on the server? I am not rendering any HTML. There's no HTML to render on the server. I'm literally serializing the props to my lazy component here. I'm sending the props over the wire so that when I get to the client, where's my Excalibur? I get to the client, I can then have the client either hydrate it or render it on the client. All I am sending are the props. I would argue with you that we've just created a JSON API. Like the server is just responding with serialized JSON data. Right? Like yeah, we've gotten back to nested loaders. Yeah, I mean, the thing is, there are solutions to these problems because you have the same model in Remix. Remix is like, what if you did the same thing but with multiple flights? The thing that I have to talk about mutation to actually finish this story. But what I'm getting at is the most pessimistic view of the world, like I hate this, would literally be just make use client everything, or client. People are asking a bit about how long Solid's going to take on this. It's not the mechanics that is delaying us. I don't know if you guys have seen the demos, like the Movies app. It's actually an API problem that has been bugging me. We have to make decisions around data fetching. Like right now, if you use Solid's version, you just use resources on the server. Like everything, just the exact same code works on both sides. The only thing that would cause a client-written component not to work on the server is accessing context. So assuming that the router is always present, you can basically just take everything that we have today and make it work like this. The problem is I'm not sure that's the best authoring experience. I don't like use client. I'm playing a lot with Bling in terms of figuring out what it means to wrap components and what that looks like. So the delay for us is not about the mechanisms, because like trust me, I'd be shouting from the roofs like about this stuff. I'm just patient because I don't want to ever ship on something that I don't have yet. Like I've shown this demo off, the Movies app demo, multiple times. This is all like server component style, incredible demo. And what I love about this demo is obviously the fact that when you go look at the network, it's just insanely small. Inject. I always got to remember to open in incognito. This is like third-party scripts, not from the site, but from like my Chrome extensions getting in here. Sorry, incognito, actual site. Sorry, wrong button. Actual site, and we'll see our 13 kilobytes of JavaScript as we walk around, and it's because we already have the mechanisms of doing the nested routing. See, swapping the nested router. We already have the ability that if we look at the XHR, you're going to see rendered markup for the page swapping out. It's just, I wasn't happy with the API, so I didn't release it. Yeah, that's what this comes down to. We have context working. One thing, we don't have the parallelization optimizations working yet. That wouldn't stop you from using it, but I think it's just worth us taking like a second shot at it, so to speak. Okay, cool. So let's see, Dan, recreating GSCP. There was a tweet. Let's see this. I think this is where I'm going to start, that we need the write-ups because yeah. My point is, on the theoretical side, like on the mechanical side of talking about this stuff, is that this scales from that static page thing with a couple interactive points to basically the same single page app you have today. That's what makes it exciting, because put all these pieces together. Essentially, we're saying that there probably is a DX win here. There's definitely a performance win on terms of the baseline, and it actually lets you. It actually lets you still cover the complete range of like what you'd want to do. You can adjust the size of this. Anyway, yes, I wanted to get into this before mutation because I think it's important to kind of understand that the way this scales. Now, I guess the big open question everyone has is like, how do I do mutation in this model, right? We haven't talked that much about server functions. And they have a key role to play in this as well. And I'll explain why in a couple ways. First, we got to go back here, right? This is where our mutation story starts. Ideally, we want to be doing the left side, well, not the right side. Right? We don't want to have a double waterfall here. And if you put 2 and 2 together, our mental model now is very much like an MPA. We have pages. Sure, we have nested sections, but essentially we do client interaction, but then when we want to, like, everything is router based. Like, if you want to update servers components, you have to change the URL. So how can you build an API? Like, what's the best pattern for it? Well, as it turns out, the best pattern for this is also the MPA pattern, because we wanted that simplification. We just need to change where this line is, right? Right now, we go to the server, come back, go to the server, come back. And in a sense, you can view that this is all, like, up to this point is like client, and then, you know, like, how should I put it? Like, we need to change, like, this is a very bad illusion, but we basically need to change where this line is. Like, the only difference between this and this might be where this is happening, so to speak, right? Because if I cut it off here, it's like the same as the first one. Okay, never mind. That use the diagram didn't work. Right. Let me try this again. I want to take Remix's model, or what we've been doing in Start and Quick and all of those. I want to send a mutation, but I instead of responding and invalidating, I want to respond with the next page. So the way I would personally approach this, if I was designing mutation, is understand that we have 3 goals to accomplish for designing mutation. We have, first, we have the like, doing the mutation itself. Okay. We have optimistic updates. And then we have invalidation. Okay. These 3 parts are part of this equation, essentially, for how we design mutations for I think any of these solutions. The thing is, this is the part that always, why I couldn't, like, practically watch Kent and Dan talk on the stream, was because they're, like, the Remix and React are so aligned, except for the fact that the React, like, next version is so much more optimal than what Remix does. But, like, philosophically, they are, like, so aligned that the argument was, like, getting really, like, painful for me, because it's like, you guys would, like, agree if you spent the time to look at each other's projects. Right? So I don't know what Next is doing, but I don't need to know. We can design this right now the same way that I was doing in the document, and we can basically, I'm willing to bet we can get 80 or 90% of the way to whatever Next lands on. Like, these things are kind of discovered, not invented. Like, we can figure out what we should be doing here. So, first thing, and we do have some hints, and this one's very obvious to me. Let's talk about doing the mutation. You got 2 options: REST or RPC. Okay, well, we know which one wins there. This seems maybe obvious to me, but it's because the way I designed it, right? I looked at, when I worked on Solid Start, I looked at Remix and I was like, oh man, this is a really good pattern. But I was like, I really dislike that the actions are tied to the URL. You can only have 1 action per URL, whatever. And SvelteKit kind of took this much later, to a different level where you could, like, split the action to multiple parts. But that wasn't, like, fundamentally the problem for me. I wanted fine-grained updates, and I didn't want to associate the file system. It's not enough to split up the action. I actually want no correlation between the action and, like, the URL, like none. I like get the rest out of there. And what gave me this idea is the same influence that React team would have. GraphQL made this solution really obvious. The funny thing is, if you look at GraphQL and you look at the queries, like, do I have like, is the Star Wars GraphQL still up? Like is the graphical like Explorer thing around? Can I get in here? Like, can I? What is it? Swappy? Like, does this stuff still exist? I don't know. Okay. Can I explore the? No, I want to explore the schema. Maybe this one's not the one I'm thinking of. It's just so much easier. Yes. Okay. Thank you. Okay. But this one doesn't have mutation, so I can't really show it. Damn it. Okay. It's really obvious if you worked with GraphQL what I'm about to say. But what I'm getting at is you design out this crazy tree on the query side, on the getter side. It's a graph. Like, you have nodes that have nodes. You have friends that have friends. You design out this tree, and all the data points are connected, and you have nesting, and you can kind of reach your fingers down through the tree and pull out exactly what data you want, right? But on the mutation side, it's just a bunch of flat mutations. It's just like, get this, post this, do this, do this. And sure, your response can include part of that tree, but generally speaking, the get is a graph and the post is an RPC. Like, I realized that, like, this is the way. And the funny thing is, I built, I was involved in a project called Backbone RM where we built like a crazy kind of pre-GraphQL trying to solve similar problems. But we built it on REST, essentially, but like smart cross-model REST where we could like pull stuff across. And it was really good. But like, the challenge that I noticed while working on this was that on the fetch side, I never felt wanting. I was perfectly happy with like a walk-through graph, through this like crazy, we could query fields on related fields. Like, we merged Mongo and database and SQL into the same query format. It's one of the coolest things that, like, I love that. I always try to come bring it back because it was like a universal query language built on JSON using Mongo syntax to work across all databases and connections between databases, and really cool, fun thing with AST, compilation and optimization. Like, I love that project. But it's too bad because the open source version it has like the 10% solution, but internally I ended up building it up for the next 2 or 3 years, and it's like, it was way more. Anyway, the funny thing is, on the get side, and I saw this with GraphQL, I never felt wanting. Like, it did everything that I needed. But on the mutation side, you get something like move, and you'd be like, how do you represent a move with REST? Because you have to like put to one location and remove from another location. It's like by like the whole REST philosophy of things. Like, there's verbs that just don't exist, and eventually you just end up making specialized REST endpoints, basically RPCs. So like, immediately, this separation between the data fetching graph and the RPCs is a very obvious thing. And when GraphQL put it out there, I was just like, of course. And since that point, no interest in going back to REST, so to speak. Like, that was a lesson from GraphQL for me. So when I looked at this problem and I was like, okay, file system routing, tree, get, mutations, no, get it out of there. Those should be just RPC calls. So this is how I came to the design for Solid Start's version, and I talked about it at VConf. I think this is probably one of the earliest versions of this type of thing. But to be fair, I was inspired by many other projects. Inspired in the sense that I knew they were doing similar things, and I found out about them after I'd already done a lot of it, but they definitely did it before I did. So this is not a unique idea to what I was doing, but. What was really clear to me is that I wanted that separation. And if you've seen anything that the React people have been talking about, they've added, stop doing that. They've added use server. So my guess is use server only makes sense. Yeah, I mean, they could go a few different APIs. So my gut here is React's on RPC as well. Okay, so this is how server component mutations are going to be based off of. This is why server functions are important. Use server is a function, RPC. So key part here, separation from fetching from mutation. Okay. The next piece here we need is optimistic updates. And I think from that perspective, Remix nailed it. So I think whatever mechanism we need to do, and by nailed it, you don't need forms to do this. If you've seen Solid Start's actions, you can use a form or you can not use a form. That part doesn't really matter. Forms are going to make sense for the MPA mentality and simplicity, and I suspect we're going to see more forms. But you don't actually need forms. What you need is the whole trick to Remix's approach is you're going to need to push any like mutation into like while in flight into ephemeral state. Okay. So essentially we're going to have RPC calls at the point that we send click send on the RPC call. We're going to have to push the ephemeral state. This has an interesting side effect because you might be going like, well, how do you update stuff if the updates, like how do you optimistic update the server portion of the page, right? You might be going, how would you do that? And you can't. So you have to make a decision there. It's a client component that does the optimistic updates. It's funny, but to me, I have an answer for this because Marco, thank you, Marco Workshop. Let's see if I can find this. Marco Workshop. Is this even still around? Building a blog. I wonder if I go to the actual video and if I linked the actual... Did I actually link the GitHub repo? I can't. I should just go to the Marco org on GitHub. We can also just reproduce this case if we want to. But essentially what I wanted to show is picture, let me go to Medium. Maybe, do I have the Medium article still open? Okay. Picture this experience where you have an article and this is all server rendered. And then how do I add a comment? Okay, beautiful. Okay. Let's look at this. This is a client component, clearly, because we need to interact with them and add our comments. But we can server render all the comments the same way that we did with the Hacker News demo. But what we can do, and what I did in this Marco demo was, I made it so that I had the server rendered version, which I didn't have to serialize the data for, but I still loaded the component to render one of these. And then when I add it, I have two lists. So the optimistic update actually could show the in-flight data as a client component, and then the server can refresh with the actual data, and the optimistic update goes away. So you have to make a choice if you want to add that extra JavaScript overhead for that experience, but you definitely can, essentially. So I don't see a problem from an optimistic update standpoint in our design so far. I think we just push it into flight, into ephemeral state. Client will handle the optimistic updates as needed. Is there a world where knowing what the action is doing on the server enables to do some cool fun? Well, I think that would be challenging. You'd have to have the intent. You as a developer can know, so you can wire it up. You can go like, this is adding something to a list, but I don't know how anything else would know that, right? Like, does it require stateful server? No, of course not. No stateful servers here, right? This whole premise of server components is not about stateful servers, right? So push any mutation while in flight into ephemeral state. Use client components to display it. And then invalidation, kind of the same way we've been doing this forever with like React Query. Like, let's make it simple. Like, if you've seen Solid's version of this, our create route data, we just have a key. And then when the action invalidates, we have a key. So if I was to do this, I would just basically, because, okay, I mean, you can look at a remix, you can't see it in there, this action. Maybe solid to do MVC is the best way to do it. Let's look at solid start, right? Let's look at solid start. Not the baby food. Okay, here we go. No, sorry, examples. Sorry, I went to the wrong place. What? Examples to do MVC. Let's look at what an action looks like here. I'm not saying like the same syntax or anything, but essentially you could define a bunch of our like server function actions right here. And I just put them all here. They're all async. They do some database action, and then they like do a redirect, or they invalidate a specific key. You can basically see an API where you could just, what I'm getting at is you do an RPC call, style call, so you can just like have a function. Maybe you could feed into a form. In this example, our actions actually, I just hung a form off them, so you can like create an action and then go like take the add to do action and then do .form, or you can just call as a function and it's a thing. But this detail doesn't matter that much. So you perform an action, you do the validation, do the work, and then you write it like you're doing an MPA, like you're doing a redirect, or you're saying invalidate this data. And instead of responding to the client at this point, you stay on the server and have the server re-render that portion of the page. Mutations, you have to kind of conceptually re-render the whole page like Remix does, right? Because you don't know, but you could use key invalidation. And then let me see, I don't have an example of key invalidation here. I talk about it in our the Vite talk, but you can pass, maybe I can look at solid starts docs, start.solidjs.com, and talk about create server action. So we do some stuff, and then is there an example with, no, maybe create route action's a better example. Show pending, handle error, showing success message, refetching, invalidating specific data. See, we were just like invalidate classes, like this is an enrollment page, invalidate classes. So on one side in your action, you just go invalidate classes, and then on your data fetcher, you can be like, hey, my key is classes or whatever. Do we have an example here? Not reconcile key, React keys, yeah. You know, you can just, it's like React Query over again, but you just put this on the server. So instead of responding to the client, you just keep it. Do you have to do the redirect? If you're doing a redirect, I think technically what you have to do, you have to invalidate. So you have to like, you basically have to, you view it like an MPA. So your options are reload the page, redirect. Those are your two options. So if I was designing this, you know, so to speak, I like you basically have two options, right? It's like invalidate. It's like reload plus it's reload or redirect, and then I would add, you know, plus invalidation if you want to like have a cache. What JSX is it going to return? Are you going to like remake your view? The router is the key to this whole thing. It's why like you're like you go. I mentioned already that when you go to a new page, like you do an anchor, you click to the new page, and the router renders part of the page. So it makes perfect sense that what you would do is perform your action and then tell the app what page to render. So instead of doing this kind of thing, let's let's look at let's rework this example for RSCs now. Okay. For SCs, server components. This isn't even React specific, right? This is the part I'm enjoying, because like I'm seeing all the pieces align that I've been working on for the last couple of years. They're all going to come together really quite nicely. So yeah, so instead of write optimistic updates to the cache, we're going to do what Remix does, and optimistic ephemeral state. Okay. Send the mutation. No update cache. No render UI. What we're going to do here, we're going to separate these a little bit. And there's going to be like a little bit of work here where we don't render the UI here, actually. We handle mutation. Plus redirect invalidate. And then after we're done that, server render, and then send that response back. Like, I don't see why you would bother sending JSX straight back through the, like, you are sending it back through the same call, but you're not, like, what JSX are you going to return? Like, think about the imperative nature, like picture writing that action. Like, it makes so much more sense, I would imagine, to say render this page rather than like, yeah. The same JSX that you get from the route changes. Yeah, exactly. That's all you're doing. The only reason I'm suggesting, how do you tell the app to render that page? Like, what's the API for it? Yeah, and you get the new props to the client and everything updates and stuff. Yeah. I'm just saying, like, if we're just kind of like sketching out a solution here, like, I think this is a simplification. You view the page as like an MPA. So RPC, simple actions all over the place, distributed, forms, however the hell you want to do them, optimistic updates, handle the UI. Then you just send your mutation along the wire, have it performance action, choose what to do, reload, show error, whatever, it doesn't matter. You basically set the rules to then tell the page to re-render again, because you're going to re-render the page. You know, the key to the invalidation is if you have a long-lived cache, you can save work on re-rendering that page. You can be like, oh, none of this data changed, only this data changed. I am going to only like do the work to re-render or refetch that part of the page. Like, you can save yourself future work. This invalidation is kind of like extra. You just moved it to the server. But as a model, like, we're just doing the remix thing. Yeah, no, this live view is so different because it's stateful. This is literally like this is stateless. This is just essentially an MPA like experience, except you get client side nested routing and you remove all the waterfalls, and it scales from MPA static all the way to single page app. Like, this is like a home run. I don't know what's the debate here on that side. It's stateful if you have a cache. Yeah, okay, sure. So, and every app that has a database is stateful as well. Yeah, I understand. Like, there's a session here. The state's specific to the end user. It's stateful. I'm just saying, like, we're not like keeping. We're not keeping. The stateful caching level is probably going to be at. It could be fragments of HTML, but it's like at the. it's not like you're going to sit there, like the live view example where you sit there and you jam a counter and it's updating the counter on the server and sending back the diffs, right? This, like, I realize you can do hybrid. They're adding client actions to live view. We saw that. This model is like mostly do the stuff on the page, only do the server components when you navigate. Like server components are a routing, like the server component part is a routing concern. That's why you can pretend like, essentially, like treat it like it's islands. It's Astro, more or less, until you talk about routing. And then you're like, okay, well, now we just kind of like get to keep everything we like, you know, from that perspective, that we can preserve our state. But generally speaking, yeah, if this was me designing this API, which I've already mostly designed here, you can see Solid already has almost all of these pieces. You know, instead of use server, we have server $, optimistic updates. You know, you've seen all this stuff in these frameworks, Remix, Felkit, they all have it. Like, it's, yeah, we'll see. I have no clue what RSCs land, you know, but like, this is the logical way one would approach this problem. Okay. I do think there's a couple points here, because this, hopefully, we've done the whole mechanical drive here. We talked about performance, we talked about developer experience. Because as I said, you just write actions that, you know, reload part of the page or navigate, very MPA-like, you know. I don't know if everyone's going to like writing forms, so like maybe that's contentious. You know, you just create an action, call the function, have data validation. This is kind of the model, though to speak. I think if they add, you know, key-based validation or something, kind of like TanStack, that was like the moment that I was like, okay, all the pieces fit together. RPCs let you do that because of the separation. Like, I think, yeah, I think they're probably in a pretty good place for the mutation story. As I said, I don't know what they're going to do, but like this seems like I got to stop saying the obvious choice. Watch them do something completely different, and then I look like an idiot. But right, exactly. They built their own transitions. They built their own placeholders. They basically built transitions, built suspense, built all this stuff. And React's like, you don't need to do all this stuff. We have a more optimal version built in. Right? It's the real challenge here, in my opinion, it's that, and I've said this a couple times on stream, it's that when React looks at Next, they're like, wow, I don't even see Next anymore. I just see React. They're so like proud of themselves of having accomplished this, you know, their vision. But when Remix or Gatsby looks at Next, they see Next. They don't see React. They see Next. So like their product is different. Somehow the problem is it doesn't matter the intent. If every product that uses React looks like Next.js, what's the differentiating edge, right? Like by consolidating, it's basically grounding out the uniqueness factor to a certain degree. And I think that there's a certain aspect of like, yeah, well, these problems are solved. Don't worry about them. Work on making better developer experiences. But so much has been invested to solving the issues around React over the years that people are invested in those solutions. So, yeah, I mean, it's a lot. I'm saying that it can scale across the whole thing. I'm saying that there are problems in the implementations today. I'm saying that there's missing pieces. But I'm saying is conceptually, like talking about this level model, if you accept the model, it should be able to cover all the use cases. What it's done actually is taken the classic single page app use cases and made them broader. Now this might actually be good enough for e-commerce. That's basically what I'm saying. I also saying that because this is an architectural thing, it's not React specific, that there's a lot of interesting implications that can come with this that I suspect that within the next 8 to 12 months, there's going to be other competitors, even sooner, that might make this even like there's a high possibility, kind of like with hooks, that React isn't the best server component framework. Like there's better server component frameworks. It's kind of interesting to me to think about. I think one of the challenges here is size, right? Because people do toy demos, right? So you're in this interesting zone where do you guys, let's do a little math together, right? Let's do a little math. Okay. So what do we got? We got the library. Say the library is size. What else do we need to be concerned with? We have the library size. We have cost of server components. We have application size. Okay. Whole. So we have like, what do we call it? Island size. Spa size. Okay. Let's just play with this framing for a second. Okay. So let's take React. Let's take Next. Okay, 80 KB. I'm actually being, that's a little bit mean. 70 KB. Cost of server components, an additional 10 KB. And your app, this is completely fictional. I'm just putting numbers in here. Let's say your island size is 15 KB. It's a pretty simple app. And that used to be a spa that was 170 kilobytes, okay? Now consider solution B for this same site, where the library size is 4 kilobytes. The cost of SCs is 5 kilobytes. Island size stays the same. And we don't care about the spa size. What I'm trying to get at is the reason I want to bring up the spa size is you went from a 170 kilobyte site down to a 105 kilobyte site, or sorry, a 95 kilobyte site. But some competitor on the small size scale is going to have a 24 kilobyte site. Yeah, a table would have made more sense, because I want to change the numbers again. What if, so like for toy demos, we're going to see this a lot, where we're going to see like this kind of math happening. Like toy demos might even be simpler, because the island size might be more like this. So a 90 kilobyte site versus like a 19 kilobyte site. But if let's build something a little bit more drastic. Let's pretend my site is 500 kilobytes or something, and my island size is 70 kilobytes. Okay. No, let's make it bigger. 120 kilobytes. What I'm trying to get at is that people are going to be pressed with this choice where they're like, they're going to be like, wow, I went from a 500 kilobyte site down to a 200 kilobyte site. This is amazing with this technology. But then they'll be like, should I stop there or should I go to 120? Like, it will be very realistic over this time period that sites will be half the size of RSC sites, because effectively the size of component scaling is a constant here. But because RSCs shrink the size of the component size, the comparison of here actually gets more emphasized than it would have in the past. Because if you have if this as a SPA framework, let's like do them like this is a SPA framework. Sorry, let's put the SPA size in here. The difference between these two as a SPA framework would have been something like let's see here, 9. Let's get rid of the cost of SCs. So basically 476. Yeah, like 430 or something. Let's say 420, right? You would have been like, wow, if I built this app in React, it's 500 kilobytes, but if I built it in Preact, it's 420 kilobytes, right? You know, like that's the kind of comparison you're going to be doing. But when people go to server components, it's going to be like more emphasized. It'll be like, oh, I can make my site half the size if I don't use React. Right, and maybe it won't matter, right? Performance is good enough. But I'm saying this is going to be very compelling when you can basically make sites the size of an Astro site and get the same experience. Yeah, so yeah, it's interesting. And I want to point out, I just said something that's not completely true. There's a difference between server components and client components and MPA islands in terms of what components. See, if like if you do you know let's look at a website. Medium, is that good? Maybe you look at Twitter, whatever. It doesn't really matter. Let's pretend now that we've built this with our RSCs and MPA versions of this site. In our RSC version, this stuff's all static, right? We don't need to do anything with these links. This is an island over here. Do some edit profile stuff. These numbers might be islands because they update with like WebSockets in the background. The thing is, these are going to be islands in a server component world because when you click, you know, you're going to swap out this content on the server, presumably, but the nav is actually in the parent section. So you're going to actually update the styles with a client component that updates. So technically speaking, you're going to have your navigation stuff is going to have some JavaScript around it. Maybe your forms are going to have some JavaScript around it. Maybe some error boundaries type handling stuff. You're going to have more client components than you would have in islands. Because in islands, you don't care. This line will come from the server under like MPA, not islands, I shouldn't have said it. With an MPA, you don't care because this line will come back from the server, essentially. When you click on the next link, this will not be an interactive component. So like, I forget what it was. It was Quick made the movies demo, right? And you remember this? I was like sitting here, you know, talking about like salivating over how awesome this app is because it's like interactive and it's got the JavaScript and it's doing all this and it's 13 kilobytes. Well, if you built this app as an MPA, not as a server component demo, it would be 0 kilobytes of JavaScript, right? Like maybe one of these effects loads a little JavaScript, but like building in this as an MPA doesn't require JavaScript to navigate around because when I click this, it'll refresh the whole page. Whereas if server components like this, I actually need to keep, you know, the active state of my links. I need to, handle a few other things. So it's not like, from a size perspective, an MPA with islands will still be smaller than a server component, not just because of the router, but because of like certain interactive points that you just don't care about in an MPA because you know it'll come back from the server. Right. So the navigation and nested layouts, you could do it with links. Yeah, but that's not the natural way you're going to like siphon off your app. You're probably not going to draw the links. I mean, you could, but you're probably not going to draw the links with on the server. Probably not. But like, you know, there's still interactive parts. Like I always love showing this demo because this shows off like the diffing because your input doesn't lose focus even though we're swapping the page out under you here. Right. This is the power of keeping the state with server components, right? Like that you can basically, you know, not lose input focus, do all this kind of stuff. But I do want to point out like this, you know, this is a client component here doing a bunch of stuff. And it's quite possible that with an MPA, you wouldn't even bother like I'm sure you would, because you'd have autocompletes and all that kind of stuff in like a real site. But I'm just saying, like, it's these kind of considerations, because in an MPA you could like type something, and because you know it's an MPA or something, the experience might be different. You click submit and then you do it, and then this was actually just an input with no JavaScript. I just want to call out that generally speaking, because maybe you don't have page-to-page transitions, in the same way, like there will definitely be more JavaScript in a server component than in these MPA scenarios, but the difference is so much smaller. This is still a significant jump. The same demo in Solid Start without islands is over twice the size, and SvelteKit's I think SvelteKit's about 35K, Solid's about 30K kilobytes. To do this, like I don't mean the initial load. I did a test essentially where I refreshed on like the main page, navigated around a bit, and then just counted the total amount of JavaScript sent. And obviously, initial load is better than that. But when I did that comparison, it's significantly less JavaScript over the course of the lifetime. And you might be like, who cares? Initial load's only what matters. Sure, but it's this approach just lends to it automatically. You don't you write your code this way. You don't have to think about it. So, yeah, islands and server components ultimately do have different implications on code size. It does impact the math a little bit. I mean, beyond just this 5 or 10 kilobytes that I'm calling out here. But so I do want to kind of put that out there, that there are differences, but I think for most people, you just need to I know it's so terrible, reverse the thinking and go we're back to building for the web. I don't know how. It's so funny because all the stuff sounds so like euphemisms almost, or hyperbolic, because you're just building towards the web platform. This is not actually the web platform. It's just this kind of MPA mentality of just pages and posts can still scale up to interactive apps with great developer experience if we do it right. So, yeah, I think there's a lot of really interesting stuff here, as long as you can kind of see the justification. And I think part of that comes from just understanding that this is not out of thin air. This is actually kind of a progression that almost everything we've been working on the last decade has gotten us to. This isn't just hey, let's, mess around with stuff because we suddenly care about performance. It's all the aspects and learnings about client-side caching, mutation, optimistic rendering, waterfall reduction, all that stuff is just getting wrapped into the architecture itself to produce something that is a little bit different. It is not a single-page app. It's not a multi-page app either. It's something else. It's something kind of new. And regardless of all the optimization techniques that we're seeing out there, stuff maybe resumability or different kind of approaches to the hydration, it still comes down to the routing being the foundational piece in understanding what our architecture is, and all signs point to it being hybrid. This is JS turning 30ish. Yeah, I can get on that. All right. So, do we have any questions? Was what I'm saying make sense? I noticed chat got quiet the last 20, 30 minutes as I'm giving my long tirade. At the beginning of the stream, there was a lot of people who had concerns. This is when I'm going to address them. If you want to poke a hole in any of this, worried about scaling, worried about, what this can do, let's talk about it for a few minutes before we get into This Week in JavaScript. All right. Dan did another tweet during the stream. Yeah. I think it would be even cooler, because Well, we already know what that looks like, right? If you've used Solid Start, you kind of get an idea of what that looks like. And the reason is, like, so many of these things just get automatically handled for you, right? And it feeds into, like, it's funny. Server components are coming in right now with this DX thing where everyone's like, oh, you can just use an async thing and then you don't have to worry about a local component fetching. The thing that enables that, if you've been following along here, is not the server components completely. Because I described how you do this with like a universal router. It's just Suspense. Suspense can't prevent waterfalls, nor can all this async component stuff everyone's talking about. But once you have Suspense, it's so nice because like you can just like do async stuff on the server, and then it just works and it streams and it comes out. Like you don't have to, all that coordination, just, it's handled for you. Race conditions, all that kind of stuff. And again, I because I'm always worried about bugs and implication stuff, I haven't been pushing a lot of the Solid Start stuff, but like it's been like that part of it has been a pleasure for the last couple years. Like it's so much obviously nicer to deal with than like having to do with the blocking stuff. Like I understand that the blocking stuff made things easier, but once you can just like go, oh yeah, I'm going to fetch this data, wait for this data, and have it all just stream out and load, and you go, wow, this is like, I'm getting the optimal performance and I didn't have to do anything special. Automatic data serialization. Like when you put all the pieces together, you're just like, this is really quite nice. And we've been living in that world even without server components for the last, couple years now. It's kind of interesting that React kind of probably intentionally held back on a lot of this stuff so that it would all come together in this final solution. And it's trickier because not everyone was willing to wait. But I think that we are getting to a point where like that reality is going to be soon. I'm looking so forward to like when I get a little bit of time to kind of come back in here and kind of finish up that part of the story, at least on Solid's side. As I said, I've very much taken my time with the APIs, and we're learning a lot about server functions. And Bling is a really good way to experiment on these patterns to understand what we like on the API DX side. But like on the mechanical side, you can already see it. It's so good. Super fast, super small. Like the second I saw that Movies app demo, especially, I was just like, I don't know if I ever want to like build apps in a different way again. Like it's basically the years fighting against this stuff, like the JavaScript size, the creep and all that. And it's just like, it's gone. It just works. Like the model dictates the benefit. Like you're still going to be able to get yourself in trouble if you do stuff that like doesn't scale well. But like the default, like random guy builds a blog site, gets basically Astro like performance, but can just write it like with something like React or Solid or whatever. Like it's just, I don't know. It's going to be interesting if React can actually deliver on the promise. That's remains to be seen. But I am not concerned with the paradigm from us finding the right DX, so to speak. And I'm not concerned on the paradigm finding the right performance, maybe outside of React, if that's a concern. Both of those are not concerns for me. Right. Don't get me wrong. I think performance is very important for that reason, among other things. But I guess the question is, like, if you view client-side cache writing and stuff and all that as, like, optimizing for performance, you're already there. Like, this just is like delete, delete, delete. Do you know what I mean? Like, that's why the DX part of the story kind of comes in, because, like, the base case is more performant and it's simpler. Well, I don't know. I think architecture changes are harder. It's going to be harder for React themselves because React spent the last few years going like, look, we know, stay the course. You don't need to pay attention to this new stuff. It's not big enough or different enough, They didn't do it, but the community, the whole ecosystem's kind of been working on that. Like, no more JavaScript fatigue. And now it's like, no, you guys, we should change what we're doing. Like, people are like, at that point, it's kind of like everything's new again. It's kind of scary. Hooks was easy to adopt. This is harder. And at this point, you have to start thinking about what this means. It'll come much faster. I'm going to guarantee this. Okay, here's the thing. This is a general architectural thing, so much to the point that even if the Angular core team doesn't get to it, someone's going to build this on Angular for Vite in less than 2 years. Guaranteed. This is not going to stay in React land. And if anyone wants to do that and wants to know how, talk to me. I'll help you. What could compete with server components in 5 to 10 years? A lot of things. WASM might finally get to where we need to. It would be interesting what that looks like, but I think there is still potential for that. The thing that I'm not really emphasizing here that I should be, that like the missing gap that makes me really excited for the future about this, is what you're seeing here is a layering. Like, Dan's tweet is actually really good at showing the layering, because he's showing, okay, initial code on the server, then on the client, and he shows this layering. This layering could also extend to build time. It could extend to edge versus serverless. And I'm not suggesting just the server component thing. It's true about the $bling operators too. We're talking about distributing a monolith across architecture and across time, like when you do the building and when you do it. So essentially, this is the area of exploration, which means that when I talk about WASM, I might be talking about, how it can apply to optimizations in a certain place. Like, the biggest question is going to be around granularity, right? Server components are saying components of the right granularity. Here's the props. That's what we serialize. It makes it really dirt simple. You don't have to worry about the details. An alternative approach might be something more fine-grained, like what Quick does. The reality might be somewhere in the middle, where certain decisions are always coarse-grained for simplicity and other ones are fine-grained for, efficiency. So like server components are coarser-grained, server functions are finer-grained, like that kind of split. So there's a lot of variations on it, but when I step back and look generally, it's all solving the same problem. It's like making sure that work gets done closest to like where work needs to get done, so we can basically distribute our app in a way that is efficient for everyone across the whole spectrum. That's the big takeaway. This isn't about server and client. It's not even mobile or whatever. It's about taking monolithic architecture and being able to use it in an efficient distributed way without it's like microservices for everyone without writing a microservice. No, it's like, this is the challenge here. Server you instead you write a server component app and drop your app into it. It's like Astro. How do you move a next app to Astro? That's the same thing with server components. Am I right to say it's improving DX in cases where you're already optimizing for performance, dealing with cache and whatnot? Yeah, and then the other case, it doesn't matter. So it's like no worse. So it's basically just like, for the most part, like a net positive. I think the place where I start seeing the friction here comes in is the fact that the server and the client, like it's about DX where the friction comes in as well. It's about understanding that the server and client models, like there might be different data fetching models, I trying to unify that is probably the biggest challenge here, and we might be being too prescriptive now. Like, we're hoping that by putting everything together into the same patterns, we can kind of like eliminate that as a concern. I find that's never completely effective, but I think that's where the challenge is. Like, where it's like use versus async component, that split. Like, why is there a server component, client component? And what we're saying right now is like, it's good to acknowledge that there's these different zones, because you can optimize for them. So that's a performance consideration. It's good for your sanity too if you think that way. There's an argument, and this is like the 5 to 10 year question and like the quick question is like, should a compiler optimize that for me and not worry about it? It depends on how much you want to give up that control. So I wonder if I see this kind of a separate side of it. Like stuff like forget is interesting because it helps improve React code, but like again, you have the same transparency thing. There's always trade-offs when we add on this stuff. I don't want to sound like this isn't going to hit its new thing. I think there's so many dangers you can see in this right now when we start encouraging people like, oh yeah, waterfalls don't matter. Like if we say that officially, it will come to bite us 100%. Like we'll be like, oh yeah, we wrote all our code with waterfalls and now we want to move it all to the edge. So we actually don't like those waterfalls. Like it's better, like stuff will change, but I think, yeah, I can't speculate on the impact on stuff like forget and that, like, because it's all about balance. Right, and this is kind of split here, but there's nothing stopping you using the current way, right? Server components are a routing thing. That's why I said the name is really bad. It's like an architecture, like a routing consideration. So if you're on a page and it's interactive and you're like, oh, I want to freaking change the profile photo, then like you have a couple choices. You can just change the profile photo, or you can just like go, hey, doing action, change profile photo, and then in the background it diffs. Like I don't know if that's like. In both cases, you just hit an endpoint, and it's the difference between the endpoint being like, hey, I'm going to, like, it saves duplication in a way, and I haven't talked about this much, and I hit this a lot with Solid Start, because when you're creating an action, conceptually, pretend we didn't have an action primitive, you're just like hitting an RPC. You know at the point that you do the processing on the server what you should be doing. Like, you're like, oh, I've added the item to the list. Let's go to the details page. You know that information at the server. But what you have to do then in a classic single page app, the API has to go, okay, indicate a success. Like it depends on where your logic is a bit. Like maybe that's a bad example because success case is easy. But like there's a certain point where you end up like duplicating logic between client and server in order to like do the same action because you know that the server will do it, check the thing, and then the client has to know how to handle the exact same thing again. So you have to communicate that as well along with the data. And to be fair, that decoupling can be very good because it means that you're not tying your back into your front end. But what this is actually suggesting is we just want to move the line of what is front end further back. So the coupling is actually good here. Where, if you want that abstraction, have that abstraction be between your data service layer and the action, not between the action and the front end, right? It's a matter of like figuring out where these things belong. And I think this is why it comes down to learning in patterns, because you can still do it the old way if you want to. I just suspect you won't. Yeah, exactly. So like, that's the thing. Like, I think this is an exciting time, seeing these things. Anyway, it's done in the 90s. Yeah, I don't know. These things kind of keep on coming around, so to speak. And the reason they keep coming around is because the desire is still there. There's the hope of unifying the document web with the application web. This seems like the best way to do that so far. I know there's a lot of friction because here's the thing. This model puts stuff like TanStack query into question because it's kind of built in. We moved the line back, right? Where that stuff's happening is in a different point. It puts, so a lot of the data fetching libraries, state libraries, their impact drops, but it has other implications, right? I think the only reason the React team's even talking about reactivity is because they're like, look, if we think we're in a server component world where like 80% of the world's server components, maybe we can make that concession to reactivity in the client because it makes sense because there's like, it's just the really interactive parts. I don't agree with their argument or logic there, but I'm just saying like, it starts changing the way you think fundamentally, which means it's not just changing the way we look at the server, it's changing the way we look at the client, which is scary. That's the part we have to like acknowledge here. This is not just a feature. It's not just lakes. It's not just like, oh, I optimize this one thing. This is not about optimization. This is about actually changing the way we build web applications. Yeah, I talked about this a little bit. I don't know for sure, but we designed it on stream about 30 minutes ago. What I'm saying is, whether it's a form or whatever, it's that mentality. We need to, just to kind of go over this a little bit, we need to use an RPC. Did I draw it any better anywhere else? No, I just talked through it. Unfortunately, you might have to watch the video to get a better answer, but we're going to do an RPC that's going to push whatever that mutation into flight into ephemeral state. And then when we hit the server, we're going to do our action, with on this RPC, and then direct somehow the page to reload or redirect, essentially. And that reload or redirect is basically just re-rendering the page with RSCs, and then the client will get the rendered HTML, JSX, whatever, the generic term, and diff that. But basically it's gonna be like a forum post. It's just gonna be with the ergonomics that we choose. But conceptually, I think we're thinking in pages. Ultimately, I think it gets simpler at an introduction level. The problem is when you come in, this is why they're playing the whole framework thing. When you come in and you're going, I want to build a React, or I want to build a site and I want to use React for it, or Solid or whatever. What you're going to do is they're going to be like, okay, here's Next.js. Let's say you got to use Next. So you're not thinking React or Solid, you're thinking in Start or Next or Kit or whatever. And your first experience is going to be like, here's how you define a route. Okay? And in this route, you can render some markup. You're not even going to talk about client interactivity. I'm familiar with this because it's like MPAs. You teach this the same way you teach MPAs, which is actually really simple. You tell people to focus on the markup. This is part of the reason why I've been debating whether actually server components should actually be .astro files, like if that actually is a way better DX for this use case. Because when you come in, you want to just you're teaching people the web by making markup and fetching data. The component wrappers are kind of like excessive there, like you literally could just view this as like, here's my HTML, it can be JSX, but here's some HTML, here's some data fetching, and don't worry about nesting, you just made your page. And then maybe later you worry about adding a layout, and then at some point you're like, oh, I want to do something interactive. And then you're like, okay, now that you have my page, let's add a component with state. This is an interactive component. So you go and you go, okay, since it's an interactive, we have to say it's a use client or whatever term. Like, so their naming is like particularly bad in this area. So you go in and you add the use client and you go, here's how you add state to your app. And you build your client component and you put it on your page. Like, this is the path forward to this. And like, oh, how do I navigate to another page? Well, I just put a lot of the SPA concepts become advanced concepts that you might never even need to learn, essentially. That is, like, even some of the state stuff might get pushed off to like chapter 2. That's how you teach this stuff. Web fundamentals. Yeah, I keep on saying this. I don't know if Astro should go this way, but like, yeah, so the problem is if you start from React today, you're going to be thinking all the wrong stuff. This is really just like, forget everything you know. No one likes that. It's exciting though, as you can imagine, because if it's forget everything you know, this is a wild open playing field. The thing is, I think the adoption will be slow enough on this stuff initially. Like it's going to take some wins before people actually recognize the power here, which means that React will have its time to kind of come up with a good solution. I mean, that's mostly it. I don't. I'm actually really happy the work we're doing right now. We're like deleting a lot of stuff. My goal in creating Solid Start was creating a starter. I don't care about meta frameworks. I don't like frameworks. You build your own framework on top of it. I wanted to make sure that the baseline experience for building didn't require a framework. When people go, you need Next.js for this, that is not what I want to be telling people getting started in web dev. That is just, I really, really didn't want that. And so what's going to happen with Start is the work's going to go into the router. We're going to have that universal router that works for client only, server components, the whole spectrum, but the work's going to go in the router. We have Bling to do the server functions, and potentially the islands. And from there, a plugin for file system routing, if it makes sense or whatever. That's it. The framework is just an Astro for the deployment and the baseline. At that point, the framework is just not even a framework, which is beautiful, right? If someone wants to build Nuxt or whatever on this, that would be awesome. But that's not my goal here. I think that what we need is just a solid foundation. We need. I've already I wanted to create the Create T3 app of frameworks, of meta frameworks, not of meta frameworks. In the sense, Create T3 app is like the meta framework thing, where all the pieces are all independent, and it's the way you put them together that makes them the thing. For us, our meta framework is that the thing itself is nothing. It's just putting the pieces together. Those pieces might even be optional, to be fair. That is where my mind is at. If I want to make sure people can build the best things. If we get too prescriptive here, we risk, I'm trying to think of how to best put this. As long as someone can get up and started with an SSR app in an optimal way and they have all the pieces they need, then base pieces, then we've done our job here. It's some people I forget who was a Theo or was comparing that RSCs are like the React going to its roots and being the minimalist and you build thing again. No, React is become the framework. This time around, it's Angular, so to speak. And my goal is to be the React this time around, if that makes sense. Bling is, we took the server functions, the $ stuff, out of Solid Start and generalized them. And we've been working with Tanner Lindsley from TanStack as a way to basically bring server functions to everyone. So this is a foundation for not just RPCs, for code splitting, lazy loading, all this stuff that works across frameworks. Tanner is building TanStack Start, inspired by Solid Start essentially, as a React framework. And Solid's a solid framework. We realized that being agnostic was not going to serve our goals. We need to be specific in order to actually accomplish what we need to accomplish. But that didn't mean we couldn't share stuff and work together. So Bling is an example of that kind of collaboration. Who's Angular? No, React is what I meant. They've decided that they need to be the framework that has all the pieces kind of coming in. I realize that they're like a spec, so they're not really. But I think the effective result of this approach is that that's what's going to happen. We'll have to see. All right. I think if we're good on questions, I'm going to gear up right now for This Week in JavaScript. Give me a second. as I kind of shift my view around. Keep on firing questions. I'll answer them as I'm kind of getting myself set up here. But all right. Sorry, just getting this all set up. It's so weird. Twitter's been so messed up recently that like I'm trying to it's like it's fine. Like half the stuff I was looking for I can't find at the moment, but it's fine. Let's get there. This might be a short this week in JavaScript. Yeah, like I see a tweet that I did on March 4th in my bookmarks from someone else quote tweeting it, and it's like literally missing from my timeline. I'm seeing like tweets from like different stuff getting pushed up. Oh, do you know what it is? Haha. I'm in my mentions or my replies. I'm sorry. It's because of I was using Twitter to do all the examples here. Okay, I feel better now. I am not insane. All right. All right. Okay. Good. And one more, sorry. Bear with me while I just get this all set up. Let me see here. Okay, yeah, there wasn't too much solid news this week. I'm not going to worry about solid stuff. We're just going to... Yeah, that's the only one. Okay, perfect. Okay, how's everyone doing? All still alive? Actually, not much Andrew Clark this week. All right. I don't know what to think about Angular these days. Honestly, Angular is... I'm enjoying Angular immensely. They're just like... They're big enough that they can just like throw grenades in. Oh, man. I know that's so funny, but it's just like... yeah, you can like you get to a certain point, like they're revitalizing in such an incredible way that it's like so obvious because they're like catching up in really short order, but they're also so widely used. So it's just like they have incredible amount of swinging power, so to speak, that they've just been sitting on, and now they're just like they're starting to like throw a couple blows in. I'm very excited about that. All right, so let me check Twitch for a moment here. Thank you, Charlie Devs, for Prime subscription. I know I haven't been up on Twitch for the last hour or two, but you know, every little bit is awesome. It helps. Thank you. Oh, so I see a clip about create T3 app. To be fair, obviously I started Solid Start beforehand, and obviously I was doing the thing, but I want to just put out there that like that was the kind of thing I was trying to capture. It's a lot easier to see it when you have all the pieces already, but that was what I wanted to do here. I just wanted to like put some pieces together, even less than what T3 app does. Like T3 app gets you to like a more opinionated level. I wanted to have like the baseline of that. Anyways. Yeah, we could talk about millions. I know my problem is and challenge here is I don't talk about stuff on performance until the benchmarks are submitted. I don't count my chickens. This is like picture if I had talked about millions 1.0, like how and you know hype that up and then like how much a performance disappointment in it. This time, as far as I can tell, he's delivered. So I'm pretty stoked about that. But like, I just don't count. Like I don't like when the press release goes out before the benchmarks are submitted, or not submitted, but before they're merged. Like I know it sucks from a like marketing standpoint, but like generally speaking, like I need to see it solidified because quite often things don't actually end up like it's surprising like almost 8 out of 10 times they don't end up. This case I actually know a little bit more because I actually worked with him helping with a memory leak and actually like help tweak getting the performance in, and I'm very impressed with the work he's done. I'm pretty confident this time, but this is just how I do it. Okay, cool. Okay, good. Okay, I think I'm ready to go. Yeah, no, I can. He's asked a few questions over the months, and then finally one day we were kind of like debugging. He was sending me screenshots of stuff, and he's like, and I'm like, no, check this, open this. Like we were like basically back and forth doing, not on a call, but doing basically a debugging session on memory, and it led to him actually finding the memory leak. So, anyway, sorry, I'm more than willing to help anyone on this kind of stuff. And again, I love the Solid Discord. This is where I get the shout out about it. We have all the framework authors in there. So not all of them from all the frameworks, but on the smaller side, we do. So, yeah. Is it in all the Discords? No, I mean, I have a few Discords like that, but yeah. Generally though, I think Solid Discord is kind of special in that way. It makes it kind of hard for beginners sometimes. You will have like, you'll like get off track. We have like Dominic, Octane, Aiden, or Million, Greg, Leptos, Fabio Vobi, Alexis Compostate, like dozens of framework authors all sitting there occasionally getting drawn into the debate when ideas come in. And I think it's so interesting to see that kind of interaction happen. But sometimes I'm worried like people are like, I was just trying to learn how to use Solid. But maybe being a fly on the wall is helpful too. Yeah. Any of the amalgamation places like Veet is a good one. Astro is another one. We tend to get a lot of like the really performance oriented discussion though around like reactivity, especially people care about reactivity. I don't like it. I mean, why do you need any optimization? I mean, it's a fast VDOM library. BlockDOM kind of showed this new way of doing VDOM. And Million basically kind of branched that in, to together. Basically, VDOM creation had recently become like the bottleneck. Like Inferno had nailed stuff pretty optimally, except for I guess you could do a little bit more in creation. And that's what a lot of the reactive libraries like Solid and them were doing. So they've now added that creation bump up. So now for something like the JS framework benchmark, it's pretty much impossible to separate like a VDOM library from like a reactive library in terms of performance. The benchmark is hilarious right now. I mean, I could pull it up, but it's literally everyone's like 1.08 or 1.09, like, and that varies between runs. So like there's like 12 or 15 frameworks that are all the same speed that like on any given run they can like jump 10 or 12 spaces either way, just like based on what the machine did. Like we basically have like all these frameworks that are just like maxed out, and then like everyone else. That's what that benchmark has turned into, and it looks like Million is going to join that fray up there with Solid, Inferno, Voby, and a number of others. So like, yeah, I don't know. I mean, if you're interested in it, like I don't know how their size pans out. There's always features. Like it's tricky. Performance is never the single guiding thing. Yeah. The only thing that bugs me is type narrowing on signals. I know. And it's like, is that enough to like come up with a worse API for composition? It's so brutal. If TypeScript could solve this for me, like we'd just be buddies, you know. It's just like every time this, yeah, I've always had a hard time with TypeScript. I have a vision of how things should work, and TypeScript like doesn't always agree. Anyway, we got to get started on this week in JavaScript. Yeah, I mean, try sending me a message. I'll see if you do reach out. Just like ask the question in the message, and I'll see when I can respond to it. Could Esno solve it? Yeah, I mean, Esno could solve a lot of things potentially. That's why I was excited about it. Yeah, I mean, I don't know. You're happy with React. You're happy with React. I think what's interesting to me is that at a certain point, like there's a create JD app, right, which is all the same stuff that's in T3, right? At a certain point, you spend more time doing that and less time doing the React versus Solid part. So like, there's a temptation that I could say that like you might just like be able to at a certain point just like build the thing in Solid, not even really care if it's the difference between Solid and React, and just get something that's smaller and faster, and just be like, you know. But if you don't care about that, like, who cares? But like, there might be just a point in the future where you're just like, oh, the experience is like basically the same, except you know, it's just kind of like better in some sort of empirical way, and then you can just be like, okay, that's worth doing. Otherwise, just not. So, like, that I mean, these things kind of all do the same thing. So you know. You know, if performance is a concern, this might be a direction, you know. But like, this is why I'm not like I don't like when people say like, oh, it's only for performance. But I can make that argument from the perspective if I'm like a React developer. I could be like, yeah, this is only for performance because nothing else actually is that different. There's some DX changes and stuff that I actually quite like, but I mean like, yeah, you know. Composition, like, yeah, I don't know. I know this is a poor sales pitch, but like, I don't know, like, well, you're in the right place. The streams, the articles, and stuff will give you a better. Not everyone talks about the underpinnings, so to speak. So I think this is a good place to learn if that's what you're interested in. Most of my knowledge is picking up pieces, little bits from various sources, and tying with my experience. I don't have a singularly good place for this stuff. when you're talking about platform level stuff, it's a different learning than building a product. If you're building a product, go listen to Theo, so to speak. It's that if you're making a productive startup. If you want to understand these tools and where they're heading and like how these things work, you're in the right place. Right. Yeah, I'm sorry I was so bad at selling Solid there, being like, I think there's lots of actual benefits to using Solid, and when we get Solid Start stable, it'll just make that Create T3 app experience just that much nicer, so to speak, and better. But I mean, like, this stuff is all so relative to me that I feel almost tired, kind of like defending it or whatever, because like you'll be perfectly fine using what you know. So, I just hope when people do greenfield development, they like give it a shot, because like I think it's pretty cool. All right, enough. I wasted like 20 minutes doing this. Okay. Yeah, I mean, that's not the messaging that I would use anymore. I think that historically this is true. I actually think we're building something that's pretty, sorry the pun, solid, so to speak. So but like when you consider the competition and how similar different solutions are, those differences might not be enough to move from the incumbent in every single scenario. I just think that like when you get to a point where you're just like, it's a little better in like every little point, you're just like, maybe that's enough. People are looking for some like drastic change, and the thing is, the drastic change in architecture, the drastic change of the singles, like that stuff's already there. But like ultimately, in the end of the day, I'm building an app. So what? Are we going to get superficial about syntax? Like, do I have to go to Svelte and then that's different? Like there's so many little choices and things that feed into that. Okay, let's do this week in JavaScript. Okay, so all right, there we go. Stretch it out a little bit, sort of. Okay. So okay. Sorry, it's funny. I do everything as if I'm going to clip this, but then I never end up clipping it. So let's get going. I'd like to talk about this week in JavaScript. Last week was a lot for me, as I mentioned. If you watched that stream, you saw that I was exhausted. I hadn't shaven. I was like half asleep. I had my hair half sticking up, and I was just like, I tried writing 3 articles in 1 week, and I was just like done. I'd stayed up the whole night to write the Friday article. And I didn't think I'd go for 5 hours, and I still did. This week was a lot calmer. Basically, only 2 things people are talking about. Server components and what was the other thing? Jeez, I can't even remember. We'll get there in a minute. But like for the most part, the Signal dialogue had moved on. I do have a couple more Signal things to wrap off, but we'll get there in a minute. Before that, just a little bit of Solid news. I thought this was really cool. I've been celebrating stuff with Solid primitives. For those of you who don't know, Solid has a primitives library, Solid primitives, which is basically like our React to use. It has a ton of packages of like hooks you can basically use with your Solid application. And they hit a couple milestones this week, which is really cool, is that there's now 100,000 downloads per month, which, again, isn't the hugest number, but that's still pretty nice. Solid itself is about 75,000 downloads a week. So like this is about a quarter of our downloads. People who download Solid also, I guess, download this. So that's a significant, thing for Solid primitives. They also released a website, I believe, Solid Primitives Netlify apps. So this gives you an overview of all the different kind of primitives you can use using your Solid app, which is amazing because this it's just a lot of utility to make, things you might think were missing in order to develop apps in Solid. Look at all these pages of hooks. There you go. And they use a stage system for proposals and stability of these, which is really cool. It's a community driven project. It is orchestrated by people on the core team, the key part of it, but there's a whole process of submission to get them in, and this makes it really nice for contribution and kind of building towards future standards with Solid. I love this. I might be very defensive of the core, but this is like a really beautiful way of handling, like a standard lib. Oh, wow. Did we get a raid? All right. Oh, Acorn 1010, thank you very much for the raid. We're just getting to This Week in JavaScript, which I do at the end of every stream, kind of going over Twitter, what's gone on. And I was just giving a little quick plug to Solid as I got started, because obviously author of Solid.js, but our React use or Vue use equivalent library just released its website and hit 100,000 downloads per month. So it's pretty cool, and just kind of showcasing that. All right. With that aside, kind of wrapping up on the signals conversation from last week, I came across this really cool tweet. Joe Savannah, if you guys aren't familiar with, is basically lead of React Forget. Worked on Relay, worked also on the Skip language, which is a reactive language inside Meta. And he had a really interesting observation here. And again, this is probably more interesting for kind of like the Solid folks in the audience. Is that when he's developing this reactive language at Meta, it had explicit reactive types. Like, this is a reactive variable, but over time, the language actually, he realized he didn't want to define what was reactive, that everything should be reactive. And this is an interesting observation, because I think in a lot of ways it guides why Svelte is the way it is. And it's also interesting because Solid actually doesn't have a reactive type either. We have like accessor, which means maybe reactive. It could be any function. And it's because we also treat everything like reactive. We actually don't have an is signal. So yeah, it's a very interesting understanding for me once I realized that, because in a sense, we all want to move to a reactive world, but in a sense, Solid not having is signal is kind of acknowledging that maybe that reactivity should just be implicit, kind of like what React says. And in a sense, React's component model is more of a concession that like this is a really hard goal and they only want to attack this in a narrow scope, which is such an interesting way of looking at the problem from my perspective, because what I'm basically saying is, like, in a sense, I'm willing to make certain trade-offs so that reactivity is global that React isn't willing to make, because to get the ergonomics they want to reach, they're willing to like limit the scope of the reactivity. And I think if you think about it in that terms, that is basically the difference in positioning of us on that whole signals argument or discussion, depending on what you want to call it. It was interesting though, because there was some people who didn't particularly like it. When I saw this, I knew Fabio from Vobi would be like, he hates this detail, because in my eyes, primitives and components are the same coin, and he goes on about, how he doesn't like the fact that we don't know what's reactive. And the truth of the matter is, I thought of him with this tweet because I realized that when you're designing a framework, you still bring your ideals into the thinking a little bit. Do you know what I mean? Like, you still kind of like, even as you're trying to be like practical about it, because there's a time that I would have agreed with everything he's saying here. I would have been like, yeah, explicit, blah, 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 reactivity. But with Solid's design, am trying to get to a reality where reactivity is our language, even though JavaScript isn't necessarily great for that. So it's like, it's funny though how sometimes these decisions look like opposite extremes. He said that we pretend reactivity doesn't exist, but it's more that you pretend that everything is reactive. So I think it's interesting because it kind of puts Solid actually in a middle ground. There's always going to be people who are like more purist or hardcore on that aspect, and React's like kind of like on the opposite side. I often see both sides of the argument, and it's a very difficult balancing act. And to be fair, I criticize Vue often for being in the middle like that. But on the flip side, as long as you can justify it and stay consistent, I think you're okay. So, yeah, just to kind of point. Here's a similar comment. I saw this one. Adam Hale, creator of SJS and Surplus, he was like, Solid started to fork in my library. That's a little bit strong, but yes, I'll take that. And this is one of my biggest disappointments with the changes Ryan introduced. In Surplus, bodies of function components are still reactive. When you break that, you break declarative rendering, right? This is going back to this example. And I wanted to bring this up. We talked about this at length last week about like the differences between these two examples. And what Adam was saying is like in Surplus, doing this would be reactive still. So whenever count changed, then the whole component would rerun. And I got rid of that in Solid for a very good reason. Actually, I got to think Fabio and Adam go on discussing this for like 30 more replies. Like we don't need to get into it. But he said it, re-executing a component is potentially the most expensive thing a user can do. In my opinion, it's very important that it doesn't just happen accidentally, but very explicitly. And I agree. And that was the design. And this is why I like this conversation, because you can immediately see that this is not a simple matter. Like a moment ago, Fabio was talking about how he didn't like, some implicitness in Solid versus explicitness. And then, Adam, who's basically the creator of this whole paradigm in terms of the ownership model for reactivity, was basically saying like, yeah, I think we should basically default to the like most inefficient way of doing things, which kind of aligns with React. So like, there's no clear single sides on this, right? The truth of the matter is, you can maybe fix this with a compiler. But is the fix even a fix if you get away from what's actually happening? This is a very deep thing, and I'm glad these two found each other. They got to have a great discussion. I didn't have to argue the points, and I'm, this is kind of like where the signals debate. It started strong and then kind of dropped off. I got to quickly point out how quickly it dropped off because I'm going to give ML Rawlings a look here. Michael Marco makes great memes. You can see at the beginning, he made this meme. Had good engagement. Make it easy to miss. This is a pretty funny one, perhaps. This meme. Even better engagement. This meme, zero engagement. So this is my way of saying that it's funny. I actually find the third meme probably the funniest of all of them, but I think we're all kind of done with the signals conversation, at least for a while. Anyway, thank you, Michael, for that one. All right. Where am I? I'm okay, back in bookmarks. Yeah, that's a React. I mean, if you watch the React documentary a certain way, like after it's funny, he got the idea for that meme because he looked at my article, the one that was pretty popular last week with the React versus Signals 10 years later, and I explained the whole thing, and talk about all the way down to, I think a pretty important message here to understand is like where some of this confusion comes around, and like I showed this whole thing about how reactive libraries had the same pattern as hooks before hooks came out, and this might for some people be kind of challenging to kind of see these differently in actually kind of the same way when people see solid and they're like, oh, you're just like React and you improved upon it. If there wasn't that like 5 years in the middle where React was using classes, if you went from like 2010 straight to hooks, you could easily see that you might think that React was trying to improve upon Signals, but if you there was a lot of really like harsh sentiment towards it, and at the end I was just like, look, this is no secret how they feel. Watch the documentary, because if you actually watch the documentary, it's the story. Like if you have a very specific context, very similar to the context I have, it's the story of how they killed Signals. Like, it's an interesting. It's an interesting thing. As I said, it's a bit hyperbolic to say it that way, but like they feel very strong, as I've talked about in the previous stream, that they fixed a problem, and we don't have to get into it again. I think Evan, you kind of said it best here. The React thought leadership had long cultivated the narrative our model was more correct, almost becoming dogma. In reality, many engineers simply are more productive with a different one. Arguing on philosophical level is pointless. There we go. The end of that discussion. But this is essentially what happened here. All right. Okay. So moving past that. Astro and Netlify both did rebrands this week, which were really quite cool. I enjoyed this. I don't know if anyone checked it out. It was sad to see, Theo's tweet move down on the list, but Astro really focused up their message. This is a really cool website update. Love what they're doing, the branding. As I mentioned, Netlify also has a whole new brand that got dropped this week. And this actually leads into this little thing where Fred did that comparison with... we had it earlier up. Did I not quote tweet it? That's fine. Fred... No, I definitely did. What am I talking about? There's no way I didn't. Yeah, here it is. Where he looked at actual real world data, looking at the performance between different JavaScript frameworks. And you got to understand, there's some legacy here that you have to consider, like Nux 2 and whatnot. But I love how he used WordPress as kind of the bar, because it's kind of interesting. Like obviously Astro's islands give them a leg up, but it does in a lot of these benchmarks. Stuff like first input delay is actually pretty good in most frameworks. But the overall score actually doesn't give most of the frameworks, sites building these frameworks, a passing grade. The thing you have to keep in mind with this is the sample size is a lot smaller. I think there's only like, I forget, like 1,000 Astro sites in this compared to like, tens of thousands of sites or 100,000 sites in like other things. So there's that to consider. But like, it's still enough data to be able to kind of, talk about the performance metrics here, and kind of see, this kind of common trend between obviously newer frameworks, but even like where Gatsby and Remix fit into the thing, and then where Next and Nuxt are in this. I have so many thoughts about this, especially with IMP, because I think IMP is going to be a challenge for a lot of frameworks, because it's hard to... Interaction to the next paint is a metric that's designed to hopefully give us an idea of the cost of interactions. So it's supposed to give us a better idea of like how fast our sites are after page load. But the challenge is that most single page apps use client-side navigation. And that means that where a multi-page app would only have like small interactions per app, single page apps are going to get dinged for doing navigation on the client. And that arguably is better than, like IMP scores are going to be better than LCP scores. So it's like, it's a hard, this is kind of perhaps a little bit biased against single page apps. We're going to have to see how this all lands, but it's at least it helps give us an idea. In any case, I'm very stoked that, we can actually see these correlations with real data, and it gives us something to target towards. He's got like P95s. He's got lots of stuff. Size of JavaScript impact, it's the average Astro site is much smaller, and even SmeltKit's site is much smaller. This could simply be because of the type of apps being built, but it is interesting to kind of see. He's very forthcoming about this. I just recommend reading this all together. I'm going to drop this in the chat in case, just it's a good performance blog. All right, let's keep on going. Marco's been coming back on radar. This is, if you guys are familiar, Ryan Turnquist, Solid Core, wrote Solid Router. This is what he's been doing since he joined eBay. He's been working on a meta framework for Marco, and Marco is kind of like already a server-side rendering framework, but what they released was Marco Run, which is Vite-based, directory, file-based routing, live reloading. It puts the whole Marco experience together in one place. I love this graphic art. I know there's some like call out to Astro, almost it feels like with the rocket, but really cool. So this is their beta release. So make it easier than ever to get started with modern tooling to build on Marco. How's it doing? How's it going, Jacob? Yeah. Okay. Oh, sorry. There is a Andrew. Sorry, there is an Andrew Clark tweet. Okay, we'll get to that. We actually touched on this a little bit when I was talking about what we were doing with Tanner and how we chose. I get sometimes some criticism. People go, Ryan, why? Like, I really wish that Remix and Solid, just were together. Like, we could use Solid and Remix, and then there wouldn't be Solid Start and all that. And the problem is sometimes making things agnostic, like working from all the tools, isn't like the best served for anyone. And Andrew was trying to make this point, and obviously, people were not stoked about that. And people still wonder where React Native has 5% market share. I've never used Astro or TanStack Query either. It's hard to make blanket statements, and that's exactly what we do when we're on Twitter. But to kind of add to it, I do actually agree on this to a certain point. What I was trying to say here is that like React is trying to position itself as an agnostic tool now that it's kind of becoming more of a spec with stuff like server components. So I think this is an interesting balance for React itself to play in terms of being agnostic. We talked earlier on the stream about React, and Remix, like Dan, going, hey, wouldn't it be cool if you guys used our suspense and transitions in Remix, and, making the issue. And all I got to say is it's always easier for lower in the stack to attempt to generalize solutions for higher in the stack and for that to cause friction, be it web platform, render library. The lower you have the most power to optimize, but higher you may have the most specific needs. And I just want to kind of like double highlight on that because like it's the same thing with like web components in the web platform. You always have like the framework authors being like, no, like let us do things our way. If you provide a good enough primitive, we'll use it. I feel like React's going to enter that phase of the progress. So it's interesting because actually Andrew responded to me to this tweet, and he was like, I feel some people interpreted it as if you should only build for React, but there's other options that are integrated well with their frameworks. And yeah, React itself, if you consider the React Native part of React, which I do, is an agnostic tool. So taken at face value, I'm a hypocrite. Yeah, I mean, the point here is that like there is some nuance to this positioning. I don't think we talk about the trade-offs nearly as much, and from that perspective, I agree quite a bit with what Andrew's saying. Yeah, this is interesting. I think there have been studies for this. This is where stuff like the Rails model came in, and where like the React team decided that like it's better to hold and show pending state rather than fall back to skeleton. There's been a bunch of studies on this in terms of like perception of speed, perception of good user interfaces. But I guess a lot of times our metrics are more at companies based on goals, like how many people press this button, or buy through rates and stuff. So yeah, it's interesting to see the difference between what people say and what they do, and how the different metrics play. And I know from like big e-commerce, and actually I was on a stream, or sorry, a space once with Dan Abramoff, and he was talking about like some of the metrics they used at Facebook, and how they weren't performance metrics, but they were like results metrics, and how that actually impacted them finding bugs or understanding the behavior of their site, even better than performance metrics. I don't make blanket statements. I make giant sweeping generalizations. Yeah, yeah. It's the absoluteness of the talk that always makes it difficult. When you say stuff in a way that makes it sound absolute, that's where you run into trouble, right? And the funny thing is, I'm making general statement about that. I posted this once on Twitter so everyone could like poke at the fact that me making an absolute statement about absolutes was funny, but yeah. Yeah, routing is one of the hardest things to get agnostic, which is why, yeah. All right, let's keep on going. Yeah, we already talked about this. There's a really cool stream with Dan and Joe, who we were talking about, and Kent. And I have to admit, because of the remix versus React bit of it, I didn't get as much from it as I'd hoped. Then again, I knew what the punchline was, so I think it's fine. It's probably worth checking out. I think the more interesting thing that happened around this was actually a side thing where Primogen was basically giving suggestions to Kent on how he could improve. I'm not going to see it here, I guess. His thumbnail image. Because like this one doesn't work particularly well, and they gave him a bunch of pointers, and they had a bit of a back and forth about like the content and whatnot, and it was interesting to see, because there's people coming out and commenting on that, kind of talking about like, he didn't quote tweet it because that lowers engagement. Like people like Theo and Prime are so like understanding the algorithms in the game that they know exactly how to actually, ensure that. So he's trying to spill on some knowledge, and it was interesting because I think there's a lot of misconceptions around clickbait and like playing into the algorithm, what that means. But that's probably a debate for another time. All right. Yeah, what do we got here? Yeah, it was kind of funny because I was on a space. Yeah, it's fine. This joke is fine. We don't have to worry about it. Okay. Yeah, okay. Okay, we get to server. I got a couple more things. Before we get into server components, I want to highlight this talk from Pete Hunt. I guess I said the signal thing's maybe not dead, but one of my favorite things now is watching back old React talks and putting them kind of like in perspective of, where we are today versus where we are before. Because I think the most interesting thing to me about this talk was he goes on and gives code examples about Ember and Knockout and kind of showing like how React is better. And this pattern is something React did really commonly. And I started thinking about it, and I'm like, it's interesting to me how those kind of examples usually, I don't know how useful they are. I guess people find them and they're the most illustrative, but I picking apart another framework's examples usually doesn't work very well. Like, you can give your own example and let people fill in the blanks about how simple that is, but when you pick apart another framework's example, the problem is you always can find a way to rewrite it better. It was similar with my comments debate with Dan in here. Like, you go, why is the original code so convoluted? You could just write it better and then just not even have this problem. And I think what was really interesting for me about this talk was he was pointing out a lot of the syntax issues, like superficial kind of issues, as well as the mechanical issues with the KVO frameworks of the day. And when I looked at it, I realized almost all the criticisms he made against those libraries back then, he could make against React today. And that's interesting to me, because it's like, it's that kind of shift. This talk really highlighted it for me, because he was talking about this Ember example, and it had this implicit mutation that wasn't getting tracked. And the problem there is you should be explicit about setters. You definitely shouldn't just like, he had a sort or reverse or something. And the problem is those APIs are mutable instead of immutable. So it wasn't like obvious why the thing wasn't updating. And if you provide a mutable API and then you use mutation methods that aren't tracked, things break. And the solution for Ember was to add the items to a dependency list, which he kind of makes fun of, right? He's like, well, I guess you can just do this, And then like, it was interesting to me because like, I was like, is that the solution to doing it in React today? And like, kind of like, to be fair, Ember had its own syntax around it, but like, in a sense, it was, the problem Ember had was both sides. Stuff was not explicitly set, and you had to do these dependency arrays, where in React you don't have this problem. But it was just interesting to me, because I actually don't see any problem with the dependency arrays. I think it's a very explicit way of handling stuff. It's just that kind of, yeah, it's funny. It's probably worth just looking at the talk, because React of the old very much embraced the ideal, and then over time had to work at optimizing patterns, intent, all this kind of stuff. That we're in a very different place than like those arguments back then. Another example was, he was talking about like an example where you had like multiple derived states kind of talking to each other through different inputs. And he was showing this knockout example where it would like, you'd update one and then it would update the other, but then when you update that one, it would like knock, like something else would get out of sync, and it would like cause like weird things. Sometimes it'd even re-render the whole thing. And like, I experienced that. It was a really real thing. But then I realized that like, this was kind of like what people complain about when they use effect, right? It's about, source of truth. And we like, the lessons there, and the solution, ironically, for knockout is the same solution that we use for like React today. So like, making those kind of analogies was really interesting to me, because it feels like as much as we've gotten away from stuff, like we're still, hitting those things. And I think that's been where a lot of my focus of this friction recently has been about the signals argument, because Dev was like, hey, should you give React a hard time for following in Ember's footsteps? I guess you already do that. I'm like, no, not really. I don't have a problem with any of these APIs. It's more that they really strongly push this message, like, we eliminate this category of problem. And maybe they could make that argument at the beginning, but it's like the reality always catches up with the ideal. And I think that's like the interesting part. So, I mean, I think this was kind of this is a great talk, honestly. he's so, like, people said that like the React core team themselves weren't actually that unrealistic on expectations, like in terms of like performance and stuff. Like he was like, look, I understand that if I took the KVO and virtual DOM, the KVO version was like a slightly more performant on the small scale, and then he goes, okay, but let's make it larger. And what does he do here? I guess this is a naive interpretation, because let me see, where did he there's a version here. Let me see. This is not what I wanted to get here. No, sorry. Here we go. Yeah. And he's like, okay. Basically, he was saying like, look, KVO pays, which is basically what signals were back in the day, pays for initialization versus virtual DOM, but they're much faster to update than the virtual DOM is. So basically, if you actually do fine-grained updates, you have this scenario where the the creation time's a bit slower, but the update time's way bigger. But he's like, if you go and then optimize React a little bit, add a bunch of like should component updates, you can close the gap significantly enough that you don't have to worry about it. Like, sure, it's not 40 milliseconds, scale it up might be much, but we get to 7, like, who cares? And this is still true. And this is a very realistic and good way of looking at performance, and it wasn't them like overselling on it. The interesting thing is, over time, this sort of example changed so that the reactive libraries were actually faster than the virtual DOM libraries at creation as well. And that was like one of the big things that came out around surplus, as I mentioned. And once that happens, you can basically ignore this. Well, you can't, because you have to use should component update essentially to get to here, or use memoization to get to here, and you're just left with something that's just faster across the board. But I'm glad that the trade-offs were called out in a really realistic manner, right? At this time. So I will say this is a great talk. He answers some questions at the end too. Like, it's a whiteboard session in a university, I think. This is just really quite good and worth your time watching. Actually, let me drop this in chat. All right, and okay, let's talk a little bit more server components to kind of wrap up today. I don't think there's a ton, honestly, but there was some stuff. First of all, Dan's tweet here, which I think is a remix quote. I could be wrong. This isn't the important part. He went on a really good, not rant. Like, he just got everything off his head, and I feel like this is finally when people started to get server components. Sometimes it takes a Dan Abramoff thread to get there, but I'm glad that people are talking about it, because like, this is a really exciting thing, and I hope that more people look into it. No, I did not. You have to assume when I'm doing this that I'm not seeing anything live. Only stuff that I pre-did. But yeah, Nuxt server components. This version is kind of like Lakes that we talked about earlier. But between Nuxt, Jacob, eBay, where I think Parasocial had a great. Yeah, like, people are talking about it right now, right? Daishi's version, Jacob eBay's was like doing it, and it's funny, they all started with Lakes. The first version here, where they basically have the server components being driven by props from the client, which is, unfortunately, as we talked about on the stream, kind of the backwards way of doing it. But it is cool to see people actually show interest in this, and Nuxt is another one doing that. There's limitations on what they've done today, which don't quite classify as like the architecture, but it's but it is very cool to see all this come out. What else are we going to talk here? Okay, this is an interesting one. The topic of waterfalls. Request waterfall from client to backend, always bad, yes. Request waterfall from edge frontend to non-edge backend, nuanced, leaning bad. Nah, it's pretty much always bad. I mean, you can mitigate it with streaming, but it's pretty much always bad. Request waterfall from front-end server to co-located backend, nuanced, leaning towards win. Not win, just maybe not as bad. I don't know. It's an interesting take. I'm wondering if this is going to be a new thing where we see people talk about good waterfalls versus bad waterfalls. I hope that's not what's going to happen. There's necessary waterfalls and non-necessary waterfalls, but there's no good waterfalls. Yeah, we talked about this diagram. It was great. And yeah, this could have helped us with our explanation. I was always a big fan of container components versus presentation components. One way to think of React Server components is that they move your container components to the server so you can pass server data props. I think it's a helpful explanation. I should have included this earlier, but I think this is like the most basic way of thinking about it from a single page app standpoint. I think the benefits go much beyond that. Yeah, let me go here. Yeah, I saw some discussion here, which I flagged because I think Evan was saying that someone had actually used Bling with Vue already, which sounds, I believe you can just, yeah, with Bling. We had to clear up some confusion here because, and I think we've already done this on stream, so I don't know if there's much to say. Basically, server functions can return server component, like server generated component code, but that's not really what the power is. It's more of a way of doing RPC calls to handle mutation. So it's not about the get, it's about the post. So anyways, sorry. I realized some of these would have been much more useful during my main part of the stream, not when I'm talking about this week in JavaScript. Which leaves me with, I think, the last thing. SPA view transitions have landed stable in Chrome. Since this is the new transition feature, which is, I think, really, really exciting. They've been working on basically bringing, like, codifying SPA navigations into the browser. So, like, you can basically like freeze the old page, transition to the new page. Basically make it a lot easier to do a lot of things that we do a lot of work in client-side routers to accomplish. I think what's really exciting about this, especially because some people are like, oh, we need that for MPAs so we can move between pages. But I think what's actually really exciting about this from a single page app perspective is that this aligns so nicely with all the server component stuff we're doing. We want a minimal router in the client. This lets us, use less JavaScript to be able to handle those kind of transitions with a client-side router. I think, again, I always say routing is like when the architecture changes, in a sense, we only got the modern set of SSR single-page apps when we got push state in the browser. I think that these new navigation APIs from Chrome are going to be the piece that unlocks server components and server component performance ultimately. That's why I'm very excited about this. This might just be like part of the puzzle. I didn't actually read too deep on this. There's a whole set of features around these kind of transitions. This looks like it has to do a lot with the CSS classes, but yeah. Interestingly, mind you, this is only in Chrome, so it might be years. Like, we'll see. I'm hoping other browsers pick up. But I think this is a very interesting... I think this direction is really valuable and important. We need more support from the browser to handle client-side routing. Our future architecture still relies on client-side routing, so this is not going away. All right, fine. I will open the one more Dan Abramoff tweet. Yeah, yeah. I right. Yeah, this is relevant to what I was talking about a bit earlier. But yeah, I think we've already covered this. But I like to see this. I know that the timing is a bit awkward. I wonder how much the discussion kind of got into it. Yeah, he's talking about agnostic solutions here. See, if you want to support Preact, then you can't do this or something. Really trying to sell it. Yes, but I think that's the right approach to take from Michael. I'm hoping that they can figure out how to work together. This is something that Tanner and I spent a lot of time looking at on the agnostic router, because I kind of pushed him to say that he should let the framework handle the async stuff. Like essentially, like if you're going to make an agnostic router, leave Suspense up to React or up to Vue or up to Svelte or Solid or whatever, and basically build it that way. And I think if Remix does want to eventually accomplish that goal, to be fair, I see a path forward for agnostic client-side routing for single-page apps potentially. I've always said it's really hard, but I know what it would look like now, at least, working with Tanner. We decided it wasn't worth the effort. It's the only reason why we pulled out. I think it does start, funnily enough, by Remix actually adopting React's patterns and leaving that to React so that their abstraction can leave that to other frameworks too, because the problem right now is they're actually a bit too opinionated to work with Solid or to work with some of the other ones. Like it's fine, it can kind of work, but I think we need to leave async to the JavaScript framework now. That's domain has shifted in the last few years. Oh, it's no. Is it in the issue? Can I see? I think the one interesting thing that I like about what Remix did. See this problem is so obvious for React developers and not obvious to it wasn't obvious to me. Because in Solid, you just go like do the data, put the suspense boundary, read it underneath, and it works. But in React, if you use the data here, like the async thing, it's above the suspense boundary. So you actually need two components, which is really, really awkward from a file system routing point, to the point that the only solution is to split into separate files. Wait, that's what Next does. Because they actually have to separate, they have to hide the suspense, because otherwise you're going to be making multiple entry-level components. And I think Remix is really smart by putting this await in here. And they also came up with their own defer mechanism, which again, for Solid, we have resources that have that same ability to hold the stream or not. But these are mechanisms that, like, I guess React doesn't have yet, but interesting. So yeah, I didn't. Oh, this is worth digging into. He's got a bunch of videos and examples, and he's saying how it basically breaks transition. Okay, interesting. Yeah, I mean, his argument's good. This is why Solid works the way that Solid Start works the way that he's explaining. But you need start transition because you want to hold the routing state. Like if you switch a tab, you don't want the state to apply immediately. Yeah, you can't make it with external stores. We have that same limitation, Solid. If you'd like Remix users to be able to use Suspense fully and avoid, then yes. I think it's also reasonable that Remix choose not to support these patterns to maintain its parallel implementation. I not blah, 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 blah. Yeah, this is a tricky one. React's going to keep on building on these primitives because they're going to assume everyone uses them. And they're really nice primitives to build on top of. I mean, we have a version of them already, but when they're, it comes down to API. Like our Solid Movies app is built with server components, basically. We make it done especially to avoid this kind of UX. Oh wow. This just goes on. It's funny because I would make Dan's argument here, not Ryan's argument here. Yeah, I see. Yeah. So he concedes to Dan's point and then says, we probably should spend our effort elsewhere. Okay. Yeah. This just means this is going to be a discussion that goes for a number of months, I imagine. Thanks for sharing that, Greg. Anyway, I think that's mostly what this week has been in JavaScript. We looked a lot at, it was like the aftermath of signals and server component craze. I hope that kind of enthusiasm carries into next week, but it probably won't for a moment. It renewed my excitement to kind of look into a lot of these topics. It seems like there's like a few big things happening in every JavaScript framework right now. We're looking to compilation. We're looking into these server component type patterns. And a lot of them looking into reactivity like signals as a way to marry these worlds together in a way that's efficient. I hope that at the end of this, people better understanding why server components are like a good thing and why we should be looking at these patterns. Like even if ultimately we end up breaking things down further or using resumability and stuff like that, there's still a fundamental routing problem that needs to be solved. And that's where the work has been. And the funny thing is the router part is actually probably the easier part. So it's just a matter of working through all the like optimizations, like the parallelization, and all the DX details around deciding what's on the server and what's on the client. If we can figure that out in a reasonable way, we're seeing the start of something that, not like hooks. See, hooks, were a pattern, as I said, that people used for years before in reactivity. I'm thinking more of like a change akin to when we moved to single page apps in the first place. I don't usually say that. I don't usually talk about like next gen, use those kind of terms. But this is it. And React is not going to be the only player in town. It's very clear to me. And there's going to be some really cool solutions coming out in this space. All right. I think it is... What do we got? It's a pizza time? Yeah, it's pizza time. Thank you everybody for joining me today, and maybe check out Jacob's space. He's doing a Code in Life right now, and have a good week. Till next time.